applications. And I can see that our director of academic affairs, Professor Dr. Indranil Mukherjee has joined. Hello. Hello, is there any network issue? Hello.
No, ma'am, it is working. No, it is
Sohail,
working
is there
fine.
any network issue?
Audible. No, ma'am, you are audible.
Okay. This inaugural session once the guests are joining us. And Sohail, would you please elaborate the some of the yeah. So over to Sohail.
Dr. Indranil Mukherjee. Welcome everyone to this 6-day online ATAL FDP, Department of Computer Science Engineering and Department of Maulana Abul Kalam, Azad University of Technology, West Bengal. So we are delighted to welcome you all. Hopefully, in 6 days, we shall be learning about some trending technologies related to healthcare and precision agriculture. We have several speakers from overseas as well as from our domestic, from industry as well as the academia. So we shall be starting our session very soon. Today we have two technical sessions, and after ending the technical session, we shall be sharing one feedback come attendance link. Everyone has to provide their feedback as well as the attendance in that link, and that link will remain valid up to 11 p.m. of the night. So make sure that whenever you are filling that Google form, you should use your registered email ID. There is a field called email ID in the Google form. So you should mention your registered email ID only. That email ID, whichever you have used for registration in the ATAL portal, kindly use that particular email ID for giving your attendance and feedback. Kindly make sure that you need to be at least you need to participate or you need to be present for 80% of the session. Otherwise, there will be difficulty issuing your certificates. And please, during a session, please turn up your videos as well as your mute your microphones for smooth handling. Thank you.
Yeah, thank you. So I would like to request Professor Dr. Mukherjee to address the participants and say a few words.
Thank you. Thanks to Dr. Suparna Bishwas and to Dr. Sohail for organizing this ATAL FDP on application of artificial intelligence in precision agriculture and smart healthcare. On behalf of the university, I would like to thank all the speakers who have joined the meeting, who will address this ATAL FDP as resource persons. Thanks to Professor Shankhayan Chaudhary, Professor Sriyankar Acharya, Dr. Suparna Saha, and others from the domain of academics, and several distinguished people from the domain of industry who have joined this ATAL FDP. Thanks to the Department of Computer Science and Engineering for organizing this program. Now, to go back a couple of years, our university initiated a few very, very progressive measures, particularly during the pandemic-induced lockdown. One of these were programs in smart healthcare, precision agriculture, telemedicine, etc. And this FDP is quite a natural culmination of the processes which were initiated around 2020-21 at the height of the pandemic-induced lockdown. Obviously, I am probably not qualified enough to speak on the importance or impact of AI in these areas. There are much more distinguished speakers with relevant background, experience, and proven track record. And I'm sure that the participants will benefit a great deal from their illuminating lectures, conversations, and interactions. On my behalf, may I request all the participants to attend this program in an interactive mode so that there is a two-way communication between the resource persons and the participants so that all of us can gain something meaningful, something tangible, so that when this FDP finally winds up, there is something tangible takeaway from this FDP. And I would also like to request Dr. Suparna Biswas and Dr. Sohail to kindly ensure that this is not just an open and shut problem. Let us try to begin a series of such programs. And if possible, let us try to set up a kind of a WhatsApp group or chat group or things like that, so that we can form an entire community which will be able to take forward this initiative in the days to come. So that will be a kind of creation of a knowledge repository which will be invaluable to the participants, to the resource persons, to our university, and to the academic community, and to science and technology at large. So thank you once again, welcome you all, and I am sure that all of you will enjoy this program. Thank you. Thank you, Suparna.
Thank you, sir, for your inspiring words. And we have already WhatsApp group for this program, but as suggested by you, if it could be a sustainable process so that it could be continued in a bigger form to continue the research in this emerging domain, we will surely try. Thank you, sir. And the other dignitaries are also present over here. I just want to convey the message from our Honorable Vice Chancellor, sir, that he is out of station and he has conveyed his best wishes to all the participants and all of us for the smooth conduction and smooth processing of this FDP. And also our registrar sir is out of station, so he could not join this inaugural session. So we have the director of School of Computer Science and Engineering, sir, T.S. Sinha, sir. Hello.
Yes, good evening, everybody. Good evening, madam.
Yeah, please, sir. I'm happy to welcome you, and please say a few words.
So I congratulate the organizer, Madam Suparna Madam, and Sohail sir for organizing such a good program on for 6 days FDP program based on Society 5, which is the two examples that have been covered here. That is your precision agriculture and the smart healthcare. It's a good. So I appreciate that there are so many participants. So I congratulate those participants and welcome those on behalf of School of Computer Science Engineering, everybody, and under our MAKAUT University. So I wish you all the best, and be sure that definitely we will be getting more, say, academically as well as the industry based, where we are applying AI based applications based on your smart, and that is healthcare as well as agriculture. So thank you very much and wish you all the best. Thank you.
Thank you, sir. Thank you for being with us. And I would like to welcome Professor Dr. Nabarun Bhattacharya, sir, who is Director, SIST. Sir, can you hear me?
Yeah. Am I audible?
Yes, sir. So please say a few words to the participants and all.
Yeah. Good afternoon to all the participants. And on behalf of MAKAUT, I once again extend very warm welcome to one and all for this very important FDP. Why I say very important? Because the theme of this FDP is trying to address two major pillars of our society. That is, one is agriculture in general and precision agriculture in particular, and healthcare. Now, if you look at the title of this FDP, it is saying Society 5.0 also. So, this AI, IoT, robotics, big data, analytics, all should converge towards Society 5.0. That means for well-being of people. Society 5.0, the moot, the objective is to provide well-being to people through technologies. And this is a very wonderful topic chosen. And as you know, that in our country, 70% of the populace, they are directly or indirectly dependent on agriculture. But unfortunately, only 15 to 16% of the GDP is contributed by agriculture. So there's a big gap, and this gap can only be reduced by working on the technologies only. And those technologies are the emerging technologies like AI, IoTs, robotics, blockchain, then big data analytics, and of course, cyber security as a cover to work with all these technologies. And especially also, and healthcare domain also, a lot of healthcare data, online health monitoring, wearable devices, robotic surgeries. These are the areas they are making a lot of difference in all over the world. And for Society 5.0 in our country, we need a convergence. And this FDP, I'm sure, will provide a platform for all the educators like you who will train the young minds on this philosophy of convergence of technologies for human well-being to really meaningfully build up Society 5.0. So I once again welcome all of you, and renowned speakers will be there. And I wish all the best for this very important FDP program. Thank you very much, Suparna and Sohail, for inviting me in the inaugural session. Thank you.
Thank you so much, sir, for your time and your kind words. And HOD Computer Science and Engineering, Dr. Saikat Basu. Sir, please say a few words and address the participants.
Am I audible, ma'am? Hello.
Yes, sir.
Yes.
Yeah. Thank you very much for inviting me in that FDP. And this FDP is very much important. And AI in precision agriculture and smart healthcare for Society 5.0. And I first congratulate Dr. Suparna Biswas from the Department of CSE and Dr. Sohail Saif from the Department of Computer Application for arranging AICT ATAL FDP and arranging the funds for the departments. That's very good. And the topic of the FDP is very nice. And this is joining the two different fields, one in the agriculture, another in the medical field. So that term, and this is for the framework of the Society 5.0. It's coined by Japan. And so AI in precision agriculture, it's very much needed in AI crop monitoring, automated irrigation, fertilization, yield prediction, autonomous farming machine, supply chain optimization. As our earlier speaker told, that though the 70% of the crop prediction has been done in India by farmers, but proper care has not been, and GDP also totally dependent on them, but we are not looking into that. And that factor has been properly taken by in the FDP. And another part is also very important in poor country like us, and AI, and the AI is needed in the smart healthcare. And that term of e-health and care is started in the time of the mostly from the COVID era. So, and now the personal treatment plans, wearable healthcare monitoring, telemedicine, predictive healthcare analytics will be required. So mostly the human-centered innovation and sustainability, resource efficiency, and data-driven decision-making will be required. So again, I congratulate all the faculty members who are joining from different places and the distinguished faculty members and industry personnel from the India and abroad. So thank you very much, everybody, for joining over here and inviting me. Thank you very much.
Thank you, Dr. Basu, for your for elaborating on this topic of FDP. And I can see our eminent speaker of first technical session of this FDP is also with us, Professor Shankhan Chaudhary sir. So we are almost at the end of this FDP, and I would like to welcome Dr. Povitro Pal, HOT Computer Application. So please say a few words and address the participants.
Okay, am I audible?
Yes.
Good evening, all. Thank you for inviting me on this inaugural session of this FDP. And I have already seen that 132 people already join in this FDP. Hope so it is going to be a big success. And the title, as already said by the speaker, that the title is well chosen by the coordinator and the co-coordinator of this FDP. And I'm not going to elaborate my lecture. It should be better to start with the FDP. And thank you all. Over to us.
Yeah, thank you. Thank you all the dignitaries for your valuable times and to join this FDP, and to it's a very encouraging and inspiring words for the organizers as well as the participants, so that for the coming days we can keep this enthusiasm for the smooth and successful and effective conduction of the FDP, so that there are effective takeaways that could lead us to the sustainable research in this emerging topic. So thank you very much to one and all over here, and we would move forward towards the first session of our FDP program in very soon. So inaugural session ends over here. Thank you very much all. So within couple of minutes, we will start the first session. Sir, are you with us, Shankhan sir?
Yes, I'm here.
Okay, sir, we will.
Am I audible, Suparna? Am I
Yes, sir,
audible?
yes. Audible and visible. So, sir, we will start at 6:30 or now, whatever. 6:30.
Maybe it depends on you. I'm here.
Okay, so
Yes,
sir,
6:30.
yeah, so
6:30.
6:30.
Oh,
Yes, sir, 6:30. We are starting the session. So, all the participants, please wait. There is only 5 minutes gap. So, we will start at 6:30, the first session. Speaker is also with us. So, you all be connected.
Hello. Hello.
Yeah, yes.
Yes.
Hello. Yeah, we are about to begin the first of our FDP, which is entitled with an issue in precision agriculture, crop yield prediction. And our eminent speaker is Professor Dr. Shankhan Choudhury, sir, Professor and Head of the Department of Computer Science and Engineering, University of Calcutta. So, anyone else want to say something? Okay. So we are starting our FDP with the brief introduction with our speaker of the first session. Professor Shankhan Choudhury is the sir. So I'm starting with.
You may start, Suparna.
Yes, sir. Yes, sir. Professor Shankhan Choudhury is the professor in the Department of Computer Science and Engineering, University of Calcutta. He completed the bachelor and master programs in Computer Science and Engineering from University of Calcutta and completed his PhD from Jadavpur University in 2006. He joined Calcutta University as a faculty member of the Department of Computer Science and Engineering in 1995. At present, his research interest is mainly focused on machine learning applications like recommender systems, influence maximization, human activity recognition, etc. He was associated with the prestigious research projects on remote health sponsored by the Department of Information Technology, Government of India during 2014 to 2018. He published more than 75 peer-reviewed papers in international conference proceedings, journals, and has one patent. 8 students are awarded PhD degree under his supervision. Dr. Choudhury acted as a coordinator of the World Bank funded Technology Quality Improvement Program TEQIP Phase 2 on behalf of Calcutta University. He also acted as chairperson of the ACM Professional Chapter, Kolkata. Dr. Choudhury is also associated to AGH University of Science and Technology, Krakow, Poland, and National University, Bangladesh as a visiting professor. So we would like to welcome sir, and the session is over to you, sir.
Thank you, Suparna. Okay. So may I start now? Okay.
Yes, sir.
Yes, sir.
So before starting, I would like to convey my heartfelt thanks to the organizer and the dignitaries. Those are already mentioned in the inaugural session: Dr. Indranil Mukherjee, Dr. Tilendra Sinha, Dr. Povitra Pal, the HOD of IT, Dr. Shoikat Basu, HOD of CSE, and Dr. Nabarunda, one of our friend, Dr. Nabarun Bhattacharya. And undoubtedly, I would like to thanks to Dr. Suparna Suparna and Dr. Sohel for organizing this type of event and provide me a chance and gives me a chance to share my views regarding my perception regarding this precision agriculture. And congratulations to them. And I would like to thanks all the participants. So good evening to all. So already Nabarunda in his inaugural talk mentioned on Society 5.0. So, okay, just a minute. I would like to share my presentation at first. Is it visible, my presentation?
Not yet, sir.
Not yet?
No, sir.
No, sir.
Is it okay?
No, sir. It's not showing.
Just দেখি তাহলে আবার কি হলো। এবার
Yes, sir, it's showing now.
is it okay?
Sir.
Yes, sir.
Okay, is it okay now?
Yes, sir, it's okay now.
Okay, so now I can start. So as mentioned by Suparna, my topic is an issue in precision agriculture and crop yield prediction. I mentioned that this is an issue, but I think today, that's why I mentioned one thing within this bracket, which is based on AIoT. So today I would like to present my talk mainly stressed on this typical architecture, which is called the artificial. It's basically a blend between the AI and the IoT. So how this typical architecture is used in the domain of the precision agriculture, that should be the objective of my today's talk. At first, what I would like to say that yes, because within the theme, two issues are there. One is the precision agriculture, or we can say it's a smart farming, and another term is that the smart healthcare. Practically, I have a little bit of experience to work in the smart healthcare, but still, when Suparna mentioned me, I basically took this challenge that because all of we are teachers. So I think the precision agriculture, as per my perception, becomes a good domain where we can provide something, where we can work. The scope of research work is there, and it may not be exhausted in that way. So that's why I think that if I took the responsibility to deliver a lecture on precision agriculture, then at least the basic papers, I have to go to the basic papers, and as a result, I can present a draft paper that may help all of you. Because again, I would like to repeat, I am not the expert in this domain, but I have gone through some of the papers and tried to assemble the basic informations that may be needed to start a work in the domain of the precision agriculture. And that should be my objective. Being a teacher, I would like to communicate, I would like to share the information that I gathered to all of you. And I feel that could be beneficiary for all of you if you would like to continue the work in this specific domain. That should be the scope of the work, or the objective of today's talk. Initially, I would like to clear that. And the duration of the talk may be 1 hour or something like this. So after that, we may discuss a little bit. So I should start before going to the technical issues. At first, I would like to explain in detail the motivation behind the smart farming and what do you mean by the smart farming as a whole. Because as per my perception, if we can declare the problem in a proper way, because this is the knowledge that we gather during our experience, that if the requirement can be expressed in a proper way, then the design and the coding, that means the solution, to find out the solution will be much more easier if the requirements are specified in a proper way. So initially, I would like to concentrate on what you mean by the smart farming or the precision agriculture, because these two terms are almost synonymously used in the literature. So go to the first bullet. This is the United Nations plans to eradicate hunger by 2030. I would like to say that whether it's a feasible proposition or not, I am not going into that debate, because it depends on a lot of social issues, the socio-economic issues. But if I would like to concentrate on the technology issues, I would like to concentrate if all these things are doing well, because in the lecture of Nabarun Bhattacharya, he mentioned that the 70% of our country, the people, 70% of the people, those are related to the agriculture. But at the same time, he mentioned that in terms of GDP, the performance is not at all acceptable. This is unfortunate, he mentioned. So That means the situation demands something needs to be done in context of the agriculture. And that's why the precision agriculture comes within the picture. You can see I have identified some of the reasons behind this, that the population is growing in a tremendous way. This is the information regarding the entire, not in context of the India. The growth of the global population is estimated to reach 9 billion by 2050 and 11 billion by 2100. So certainly there could be a, in the dearth of the food, because, and not only that, another issues are that the situations are changing. Situation means the climate is changing. In terms of temperature, I mentioned, the waters are not available compared to the previous days. Soil quality is going to be degraded, or we can say the soil, the quality, the soil features are changing with time. Land use changes, so land use map is changing. The land is using more and more, and environmental pollution undoubtedly becomes a very, very crucial issue. So if we can consider all these issues simultaneously, all these reasons have a negative impact on the food production. So that means the demand is high, but the production is not as per our expectation. And another thing is happening that I mentioned in my last bullet, that the global reduction in agricultural land mass, the agricultural, because all of we are the resident of the West Bengal, we know what's the problem regarding the agricultural land. So the global reduction in agricultural land mass for cultivation, and due to rising water, this is a global issue. But at the same time, so the agricultural land is going to be decreased. So what should we do? So to cater the need, we have to develop a more sustainable and efficient food production system, and that should be the concern of the researcher. And from this motivation, the smart farming comes within the picture. So that's the reason. So the traditional mode of agriculture is not sufficient. Climates is changing, reduction in agricultural land. Moreover, some socio-economic issues are there. So collectively, it must have a negative impact on the food production. What we should do? So we can use the cutting edge technology to overcome these problems. And this is the precision agriculture or the smart farming. So precision agriculture represents a revolutionary approach. Is the slide change হচ্ছে তো?
হ্যাঁ স্যার, কারেন্ট স্লাইডেই আছে।
না, এটা কি সেকেন্ড স্লাইডে যায়নি? ফার্স্ট স্লাইড থেকে
আপনি
সেকেন্ড
যেটা
স্লাইড
বলছেন ওটাই আছে। হ্যাঁ, precision agriculture.
Precision, yes. Okay, fine. Okay. So precision agriculture represents a revolutionary approach to farming and transforming traditional practices. So traditional practices are not sufficient. I have to reach the expectation in terms of food yield, the yields of yielding. So that's why cutting edge technologies needs to be used. And as a result, the farmers worldwide are recognizing the potential benefits of PA, this is the abbreviation of the precision agriculture, in boosting productivity, reducing waste, and enhancing overall efficiency. That means our intention is to optimize the use of the resources such that the benefits, that means the crop generation, can be maximized. So it becomes an optimization problem in that sense. But I'm not going into the technical part now. Before that, I would like to explain the problem domain as a whole. So this is the motivation behind precision agriculture. I think I can convey, I can communicate. And how it can be done? So formally, in some paper they mentioned, there is a formal approach. This is called the principle of 4 R's. What are these R's? These R's are applying the right input. So precision agriculture is needed. How it can be done? It can be done through applying the right input at the right rate, to the right place, and at the right time. Okay. So, as for example, whenever we are talking about the big data, we mentioned there are 5 V's or 3 V's. In that time, in some paper, they formally mentioned that if we can maintain these 4 R's in context of a precision agriculture problem, if we can apply the right input, I can explain one by one. You can, if we can provide some examples in context of each issue, then I think it will be more clear to you. You can see the right input. So seed type selection according to the specific characteristics of the environment, appropriate type of fertilizer selection based on soil nutrient levels and crop requirements. This should be considered as a one type of right inputs. Otherwise, basically, actually what is happening in traditional way, either the farmers are doing on their own, or they are talking to some person who have the domain knowledge. So here, what is our objective? The entire domain knowledge needs to be automated through the precision agriculture, and that should be our task. So that's why the first of all thing we would like to point out what we should do. We have to input the right thing. Seed type selection according to the specific characteristics of the environment. It's not at all based on some whims of a person. So based on some facts, based on some previous data, analyzing the previous data, we can take the decision. That's for this typical environment and for this typical soil nutrient level, the soil quality, this seed type may be a good choice. So that's why the right input becomes one of the major issues if we would like to generate, if we would like to achieve our target that is mentioned by the UN. So first thing is the right input. Second thing is the right rate. It's just go through the example, then I think it will be clear. What will be the input rate? That is based on the field variations. This is one term they have used. This is called the field variability. That means within the field where you are going to generate the crops, all the portions of the fields, all the nutrients, that means the soil quality of all the portions of the same field may not be same. So it may vary. So that's why the optimal input rate based on field variation becomes crucial. So it may not be like this, that maybe from one district to another district, the field may vary. So you may not stand with respect to a fixed solution. According to the field variations, the rate may be different. I'm not talking about the right rate. That means the right input is going to be selected, but in which rate the input is going to be used. As for example, fertilizer. So you can select the proper type of the fertilizer, but in which rate the fertilizer is going to be used for that specific condition, that is also another crucial issue. Otherwise, you may not get your desired result. So right rate becomes another issue, the optimal seeding rate. And this is another example. I think it will be very interesting. It will be clear that adjusting the density of the planted seeds according to field condition. That means whenever you are planting the seeds, the density of the planting may vary based on the quality of the field, based on some features of the field, based on some property of the fields. And this is called the rate. That means the density of the planted seeds may vary. So what type of seeds you are going to be used, that is considered as a right input. But in what will be the density of the planted seeds, this is considered as a right rate. So both have separate distinct impact on your output. So if we would like to achieve the desired output, only the right input is not sufficient. The right input should be used at a right rate. And you can see that's why I mentioned it in a different color to highlight it, because studies have also shown that adjusting input rates based on field variability leads to increased crop yields and resource efficiency. This has been proved. Okay, so that means it's a accepted thing within the literature that the field variability should be a useful concern. It should be it's a concern that we should consider whenever we are going to propose a solution. Right time, the third one. Timing of planting is a critical determinant of crop success. All of you are aware about this. Ensuring that crops are planted at the optimal time depending on prevailing climate conditions. I'm not talking about the month or something like this. That means based on the data analysis, the previous data analysis, and the data analysis means not only the previous historical data and also just analyzing the features of the field. That means the soil nutrient, the environment conditions, all these things. We can take the decision that what will be the right time, what will be the optimal. I think optimal, this term is much more effective compared to the right time. Optimal time depending on prevailing climate conditions such that I can maximize my yield. So right input at a right rate, at a right time, and in a right place. So right place extends beyond a mere location of the field. So it's not the location in that sense, it's much bigger concept. This is called the spatial variability, because if you know in the computer science we have used this term, the spatiality, to indicate the spatial and temporal. So spatial variability, we would like to address the spatial variability. A pivotal tool in precision agriculture is variable rate technology that I mentioned just now, which allows for the application of inputs at variable rates across distinct zones. So this is the right place within the field based on specific needs. So that means you can see there is a single field is there, but within the single field, the same seed type is going to be used in different density in different zones. Why? Because our intention is to put the right input at right rate in the right place. Okay, so now again I would like to conclude this part mentioning these 4 R's are the key thing within the precision agriculture: right input, right rate, right time, and in the right place. So these are the 4 pillars within the precision agriculture. So now the question comes that what's the role of the AI within this agriculture? Already this is, because I already mentioned, the precision agriculture means we are basically shifting from the traditional agricultural to the agricultural solution where the cutting edge discipline can be used. And cutting edge discipline means now the data becomes the major strain. So if we have some historical data, if we have the data in context of the soil nutrient, if we have the data in context of the weather, then all the data needs to be analyzed, and this data-driven decision can be used for better yield production, or maybe some other words. Those are related to the precision agriculture or smart farming. So as a result, the cost savings through ensuring optimal resources, I think and automation impact, that is also another thing that I should mention. That is basically we are shifting, the paradigm is shifting from the human intervention to the automated solution. And the automated farm machineries like driverless tractors, IoT powered agricultural drones, these are entering within the scenario. So, and these are the automation impact. And I would like to conclude mentioning this information. Just see this. The AI in agricultural market is expected to grow from USD 1.7 billion in 2023 to 4.7 billion. So that means the huge market share we are expecting. So, and the peoples are going to use the AI in the precision agriculture. The question is how, and what are the basic perception or the basic knowledge that we should know to contribute in this particular domain. That should be my content of today's lecture. And again, I would like to use this term, the AIoT. AIoT means all of you are aware about the IoT. IoT means the Internet of Things. So initially it was Internet. Then just top of the Internet, we are proposing another layer where the data exchange are done not only among some communicating devices. Initially an Internet, the data exchange take place among some data communicating equipments. It may be some tablets, laptops, machines, server, something these. But in the IoT, that's why this is called the Internet of Things. Anything can participate within the IoT. So that means that we can exchange the information among all the things. The things means anyone. It could be a coffee machine, it could be a fridge, it could be a car, whatever it may be. But one condition is that it has to be smart enough. So what do you mean by the smartness? The smartness means in a very simple way, but we can say they can store the data and they can communicate the data. So only then it should be considered as a smart device. So IoT provides you a platform through which you can sense the data, you can exchange the information among them, and accordingly you can create the networks. And so we are aware about the IoT based solutions, and now this is the AIoT. This is a new term, new coin that is going to be used, which is nothing but a blend of the AI and the IoT to propose a solution. So one of the application domain of the AIoT is the precision agriculture. I would like to concentrate on the AIoT architecture as a whole in a general way, and then I would like to say that how the AIoT can be used in context of the precision agriculture. The AIoT-based solution you are using in the smart health domain also, and you can see these are the possible application domain in context of the smart agriculture, of the smart farming, where the AIoT is used, and already it has been used. The crop management is there. I think there is no need to explain in detail, because from this you can gather what are the possible application domain in context of the precision agriculture. Soil management could be another issue. Water management, I will discuss, maybe I will take 1-2 typical example to clarify or to provide a perception, or such that you can conceive that what we would like to do actually through these solutions. The disease management means within the plant, there may be some disease, and with time it is changing. So if we can detect in an earlier way, then we can take some action. Accordingly, some actions can be taken. This is also automated. Smart harvesting can be done. So I will explain 1-2 cases. You can go to this. One typical use case is the automated irrigation systems, because I will mostly confined with context of the automated irrigation system. This is a typical example of the smart farming. What is actually happening within the automated irrigation system? You can see an autonomous crop irrigation system is designed to conserve water. How? Through an intelligent detection of water requirement depending on soil moisture levels and weather conditions, while promoting sustainable agricultural and farming practices. So basically, what we would like to do? So AI in smart greenhouses, this is also another example. This is also another example. This is one typical example where in the irrigation system, there may be a lot of waste of the water. So now in an automated way, our intention is to use the water in an optimum way such that the waste can be minimized. This is one typical application. You can see this is another one, AI in smart greenhouses. You know the purpose of the greenhouse, that optimizes plant growth by automatically adjusting temperature, humidity, and light levels based on real-time data. So that could be another example. That could be another problem, that a greenhouse environment is given to you. You have to propose a solution which is called the smart greenhouse, and the objective in a single word is to optimize the plant growth through adjusting the temperature, humidity, and light levels in an automated way. That could be another problem. And that's why I would like to provide this type of examples such that you can feel that what we would like to do, what are the problems are. So AI plays a crucial role. This is, you can see, this is another totally different problem, detecting leaks in irrigation systems. Because the survey paper mentioned that it becomes a serious problem. Whenever we are talking about a large irrigation system, there may be huge leaks. And by analyzing, so through these leaks, the huge wastage of waters are there, and water scarcity becomes a serious problem. So what they are mentioning, that by analyzing data or framing some algorithms, you can identify patterns and anomaly patterns also that indicate potential leaks. How it can be done? It can be done to identify or to frame or to create a specific signature of leaks. That means I would like to identify the pattern through a specific signature of leaks, such as changes in water flow or pressure. So that means whenever in an automated fashion, if we can see there is a change in the pattern within the water flow, accordingly we can take the decision that there will be some leaks, and the real-time monitoring and analysis enable early detection, and it can save a lot. So that could be another problem. That is how the leaks can be detected in irrigation system. Or you can say within a simple, is a large irrigation system, these are some sub-problems. That the conserved water, this is one thing, that how the water is optimally used. And this is another thing, how the wastage of waters can be minimized. If I and this is another use case. You can see all these are the different type of problem. So people are working in this with these problems. Computer vision. This is one of the major domain where that may be related to the precision agriculture. So computer vision can detect the presence of pests or diseases. So this works by using AI in agricultural project to scan images to find mold, rot, insects or other threats to crop health. So that means you basically start after taking the images of the crops, and your intention is you have to analyze the images to find out the insects within the crops or not. And in conjunction with alert system, this helps farmers to act quickly in order to exterminate the pest or isolate crops to prevent the spread of disease. So that could be another problem. I think I'm just trying to mention these problems one by one, such that you can feel, you can conceive that what do we mean by the precision agriculture or the smart farming, or these are all these different problems that may be there, and the people are working in all these domains. Another thing is that I'm not going to, I should just, this you can see. This is another thing. This is called the automatic weeding. You know that the term weeding means that I would like to find out the unwanted plant within the field. So again, the computer vision comes within the picture. So the those are working in the computer vision, so they can start the work in the precision agricultural domain, because computer vision is used. The computer vision algorithm can be used with the AI to size, shape, and color of the leaves to distinguish weeds from crops. Weeds means those are unwanted. So I would like to exclude the weeds from the crops. How it can be done? So that's why some automated way, some camera may be there. You can use the drones also. So drone may move within the field and they can take the pictures. You can analyze the pictures, and then through this AIoT, why the AIoT comes? Because drone may be one IoT devices. All the other IoT devices are there. They are sensing the features of the soil. They are sensing the environment or something. And all they are collaboratively provide a solution with the help of the AI, such that your solution will be able to distinguish the weeds from the crops. So such solutions can be used to program robots that carry out robotic process automation, such as automatic weeding. So that can be done also. That is, if we can identification may be one task, and use of robot to exclude it, that could be another task. So I think through these use cases, my intention is to clear in front of you that what are the problems are available in context of the precision agriculture. So these are the problems, so we can work with all these problems. And these are some examples you can see. This is the examples, the pictures. Through this, I think it will be, you can feel in a much more better way that the automatic irrigation, how the water is going to be sprayed, or the pesticide can be sprayed also. And this is also, you can see this is the drone. From drone, the pictures can be taken, and accordingly the entire space is going to be divided into some segments, and accordingly based on the analysis, the insect, for removing the insect, the different type of spray can be done or something like this. So these are the typical use cases that is happening in the real world. Okay, so now I would like to go to the technical part, that is the AIoT. So this is the problem. The question is how the AIoT comes within the picture to solve this problem. You can see this is the mainly from 2022, this paradigm is going to be used in a proper way. This is a combination of AI technologies with the IoT infrastructures, and two forms for collaborating AI and IoT in AIoT system. One is called the loosely coupled, another is called the tightly coupled. So all of you are familiar with the loosely coupled AIoT, because I know that all of you are aware that if you would like to provide this type of solution, you have to use a lot of IoT devices. They can sense, they can communicate among them, and after that they are transferring the data towards cloud or something like this, maybe a big server, because in a server having a huge computing facility, you can collect the data, you can store the data, and you can analyze the data, you can execute the AI-based algorithm that demands huge computational facilities, processing facilities. So that may not be feasible in the IoT devices. That's why the common methodology that we are following, that is data is generated in IoT devices and forwarded to a local or remote location, that is the cloud, and to be analyzed by an AI-based method such as neural networks. So in the AI-based model, you can use the, mainly in case of the precision agriculture, we are used the CNN or something like this. So that type of model you can use in the cloud, and within the cloud you can use this, because in the cloud you can handle the data, huge amount of data, and you can allow the huge computational facility that is available in the cloud. So these are considered as a loosely coupled IoT. But nowadays, for this type of solutions, the people are transferring to the tightly coupled IoT. All of you are aware about the loosely coupled and tightly coupled definition. So we can guess that what do mean by the tightly coupled. Sorry. In the tightly coupled IoT devices are equipped with AI processing capabilities. Just keep in mind that small IoT devices, but they can do up to a certain extent, they can use some AI processing capabilities and AI algorithms and are run on IoT devices partially or even completely. So whatever is possible based on the typical problem, if it permits, then the AI facility is going to be coupled tightly with the IoT devices. So now the paradigm is going to be shifted from the loosely coupled to the tightly coupled, especially for the precision agriculture. So that's why I would like to mention these two terms. You should know this, loosely coupled and tightly coupled. So if you would like to compare between these two, I think now it's clear to you that while storing and analyzing data on a centralized cloud bring many benefits, including cost efficiency and high computing and storage capabilities, it also is ineffective or even infeasible for some applications that generate high volumes of data, require a high level of scalability, constant network connectivity, and increasingly data governance. So sometimes the tightly coupled may be effective, sometimes the loosely coupled may be effective. Basically, it depends on the typical problem domain for which you are proposing the solution. And as a result, all of we know that the AIoT, whenever I am talking about the AIoT architectures, what should be the architecture of the AIoT? So AIoT uses different combinations of edge, fog, and cloud computing to achieve its goals. Because all of you are aware about this term today. But we should know this because these are the spaces where we may work. Because the existing solutions are there. So being a researcher, what we are trying to propose? We are trying to improve the solution in terms of accuracy or maybe in terms of some specific parameters. So for doing this, we should know as per the present state of art, what is actually happening and what are the basic terminologies, what are the basic status. And based on that, you can plan that what we should do for doing something new. So that's why you should know that AIoT uses different combinations of edge, fog, and cloud computing. I am going into detail because this is a crucial part in context of the AIoT. So, just a minute. So, AIoT, it's and this is known to us whenever we are talking about a complicated problem. It's a complex one. Then the common human perception is that try to divide into some smaller problems, and all of we are aware about all these things, starting from the TCP/IP, starting from the DBMS. Always we are provided for this type of cases where whenever the complex situation arises, we are basically proposing a layered architecture, and this is true for this also. So now I am going to start the discussion, which is the main discussion on the architecture. What will be the architecture of the AIoT? So various architectures are available depending on the specific requirements I mentioned, but it's a layered architecture. So formally they have defined, sometimes because there is no standard one in that sense, a lot of works are available, and in most of the works, I will come to that point also, that is a summary of the existing works. They can use either the 3 layers or the 4 layer architectures. Okay, so what are these 4 layers? Start from the lowest one. So the lowest layer, a layer that addresses devices for data acquisition. And this is very much known as a device layer or the data acquisition layer. So, and why we are proposing the layered architecture, then I think whenever you are proposing the solution, it will be easier for you that initially you can think in that way, that what we are using in the device layer, what are the algorithms or what are the solution techniques that we are using in the data acquisition layers, then go to the next layer, then go to the next layer. In that way, it will be easier to conceptualize the solution. That's why the layered approach is beneficiary always. And you can see the data acquisition layers. This is the different devices, including sensors. You know, within the sensor network, the sensors are there, actuators are there. Some different type of devices, you can consider it as a sensors, or you can say in a different way, it could be a drone, it could be a camera, it could be a smartphone, RFID, whatever it may be. Just try to think all these things are used at the lowest level, and they are capturing the information. The sensors are capturing the information from the field. Sensors are capturing the information from the environment, and they are communicating among them. Okay, so what will be the communication protocol that we should use? That could be another design issue. And they are capturing the data, they are exchanging the data, and accordingly they can create some summarized information, and that may be pushed to the next layers. Okay, and what will be the next layers? So next layers, this is called the edge or fog layer. Now there is a controversy comes within the pictures, because these two terms is also well known. One is called the edge computing, another is called the fog computing. But the problem is that why should I go for the edge and fog? That is, and for most of the solutions, the edge and fog should be there, because cloud computing offers a centralized, scalable, and powerful resources for AI, such as large data sets, advanced algorithm, and specialized hardware. But edge computing offers decentralized, efficient, and responsive resources for AI, such as local data, customized models, and low power devices. So that means if it will be the case that whenever we are collecting the data, we are transferring the data. Always we are transferring the data to the cloud, and the cloud will take the decision on behalf of me, and again the decision will communicate to the end level, to the end user. Then there will be a huge latency. That's why and not only that, a huge the overhead will be more, because a huge data transfer comes within the picture, within this solution, just now what I am mentioning. So instead of that, if we can provide a edge layer, that means in some small computational capability based machines are there within the edge, and as a result, they can, based on the requirement of the solution, immediately they can take some decisions, and accordingly they can communicate to the end devices. So then the overall latency with respect to the system will be minimized, and that should be one of the major requirement of my solution, because in most of the cases, with just now I mentioned the irrigation, so the optimized resource of waters. So as early as I detect it, as early as I detect the leakage within the water pipe, so I can take the decision. So instead of transferring the instead of transferring the information towards the cloud, some computation can be done in the edge, and that's the common thing. So edge computing offers decentralized, whereas the cloud computing is centralized, where all the sensors are collecting the data, they are transferring the data. Cloud is a central node. They are taking the decision on behalf of all the small devices, and they are communicating them. So instead of this, edge computing may be a better solution. And depending on the needs and constraints of the AI application, I think you can feel, just try to visualize the water irrigation system or the leakage in the water line, and then I think you can feel that why the edge computing, why the fog computing is needed. You can see the edge fog layer refers to the next layer. So initially we start with the lowest layer is called the data acquisition layer, where the sensor nodes are there, the drones are there, camera there, RFID nodes are there. They are collecting the data, and they are sending the data to the edge or fog layer. So consider it as an edge. The next layer that receives the raw or processed data from the device layers, performs aggregation, and further that will summarize the data, and further pre-processing, including security, sometimes maybe, sometimes may not be, and then sends the result to the cloud layer using some form of communication interface. So it's basically intermediate between the lowest layer and the topmost layer, which is the cloud. So this is the diagram. I think from the diagram it will be much more clear to you. This is the device layer. They are collecting the data. Now the data passed to the one layer we are creating between the cloud and the device, edge layer. They are doing the data processing and reduction. Up to a certain extent, they process the data caching and buffering, control response, virtualization. So part of the work will be done in the edge. As a result, the data transmission will be limited and the overall latency will be better. And then cloud. So now another thing is coming. That means in some of the architecture, what they're suggesting, that between the cloud and edge, another layer we can plan, which is called the fog layer. That's why initially I mentioned that it could be a collection of 4 layers, or in some of the examples, they are considered as a 3 layer. So in some of the work as per the present state of art, the layers are device, edge, cloud, or the device, edge, fog, and cloud. So whenever I'm talking about the fog, you can see the edge computing means by processing data locally. So edge computing can reduce the network traffic, latency, and bandwidth consumption that would otherwise occur if the data were sent to the cloud. So for the time sensitive and for the mission critical task, it is very much required. And for most of the precision agricultural problem that I mentioned, that is undoubtedly time sensitive. So in that case, in most of the cases, the edge layer is needed, and that's why the edge layer becomes the de facto standard. But at the same time, there are some challenges in context of the edge computing we keep in mind, because this is my task to inform you. That is, the edge computing, undoubtedly, it's a solution to provide a lower latency and a lower bandwidth consumption. But at the same time, you should keep in mind that because as you are allowing the decentralization of the data, so that increases the risk of the data breaches, tampering, and unauthorized access. So again, the question comes that whenever you are using the edge layer, so edge device may not have the same level of the encryption, authentication, and protection, because it's very much clear that whenever there is a single cloud server, so it should be protected more. So all the security related issues like encryption, authentication, that should be properly maintained in the cloud server. That may not be maintained in the edge device. So whenever we are gaining something in terms of latency, there will be a question in terms of the security or something like this. Always with respect to any solution, there will be pros and cons. So we should keep in mind all these things, and accordingly for a specific solution, I have to find out that what should be my typical AIoT architecture. So this is the edge fog computing comes in the picture. I already mentioned that fog computing means we are adding another layer between edge and cloud. This is fog. So that means we are discriminating between the edge and fog. How? What are the issue of discrimination? You can see the issue of discrimination is the fog computing and edge computing appear similar, since they both involve bringing intelligence and processing closer to the creation of data. Why? Because our intention is to reduce the latency. Our intention is to make the data transmission as low as possible. But fog computing and edge computing are both decentralized computing models. But their difference is between the two is the compute power and the location of data processing. Whenever I am talking about the fog, so that means I am in a local area network. From the abstract point of view, the fog layer is a higher layer than compared to the edge computing. So edge computing is initially there is a device layer, then the edge layer, then the fog, and then the cloud. So fog computing and edge computing, you can see the fog environment places intelligence at the local area network. This is the major difference. So this architecture transmits data from endpoints to a gateway, where it is then transmitted to sources for processing and return transmission. But edge computing, compared to again I keep in mind, places intelligence at LAN, and there places intelligence processing power such as embedded automation controllers. As for example, just take this example. I think from this example, it will be clear to you. A jet engine test produces a large amount of data about the engine's performance and condition very quickly. It's a time critical, this I mentioned you, time critical problem. So industrial gateways are often used in this application to collect data from edge devices, because now there is no much time to put it within the fog. So use it in the edge, which is then sent to the LAN for processing. So that means sometimes, depending on the typical requirement of the problem, the fog computing is needed. So you can think into that way, that I am not going into the specific solutions, but whenever I am talking about what will be the generic architecture of the AIoT, so 4 layers are there, and I have explained the causes for preparing all these 4 layers, and what are the purposes of these 4 layers, and what are the activities addresses by these 4 layers: the device layer, the edge layer, the fog layer, and the cloud. And now whenever you are proposing a solution, you can think that what will be your solution in context of the edge computing, the edge layer. What will be your solution in context of the fog layer? In that way, I think, and this is the AIoT architecture. But at the same time, go to these slides, there is an open fog consortium. They are suggesting, because some of the works they are using either edge or fog. So open fog consortium, they are suggesting don't do this. Try to discriminate between the edge and fog, and they have provide the reasons behind it. I think this is clear here. You can just go through this slide. The fog is also positioned near at the edge at the same moment. It uses local processing and storage resources. Fog is decentralized with numerous nodes, just like the edge. Fog, in contrast to the edge, has a network architecture. Fog nodes are interconnected and can disperse computing and storage to complete specific tasks more effectively. But edge provides the lowest latency and fastest reaction to data because it is the closest to end devices. So now, based on the requirement, both may be needed. So accordingly, the entire task is going to be divided, that which one is going to be solved at the edge layer and which one is going to be solved at the fog layer. So that's why the structure in edge computing is typically more loosely coupled with edge nodes handling data on their own. This is a suggestion from the Open Fog Consortium. And except this, I think you can now feel that fog, so connectivity to fog layer, and except the fog, cloud, edge, and device layer, always there will be a connectivity layer, because the whenever I am talking about the integrated solution in context of this, just now I mentioned in the device layer, all the IoT devices are there. Now the question comes, what will be the connectivity protocol that we are choosing for my typical solutions? So connectivity layers comes within the picture, because connectivity layer relays the data between the layers. So it should be considered as an independent layers. And in some of the solution, they are using the application layer as a different layer. But in most of the places, it is basically merged with the cloud layer. So this is the diagram, I think. My entire discussion is portrayed, is depicted through this diagram. I think you can see all these are the end devices. This is the end device layer. And this is also the connectivity layer. And you know, whenever we are exchanging the data, the smart devices, small data they are exchanging among a smart, within a small distance, then what type of protocol we are using? The Zigbee, the Bluetooth, this type of protocols we are using. So Wi-Fi. So this is one connectivity layer. But whenever I am transferring the data from, you can see this is the edge or fog layer. Whenever we are transferring the data from fog layer to the cloud, then the 4G, LTE, 5G, so this type of connectivity protocol we are using. So these two are the connectivity layer. This is the end device layer. As per this diagram, one layer is the edge oblique fog, but as per our suggestion, it should be discriminated, because just going through the overall task, we have to find out what are the time critical tasks that can be solved partially within the edge. Otherwise, some of the remaining thing we can push towards the fog layer. So in that way, we should plan. But this is the generic AIoT architecture, and my intention is to stress on the AIoT as a whole. Okay. So this is the AIoT architecture. You can see this could be the centralized one, and it could be the distributed one. And you can feel that the distributed architecture becomes the ideal. This is now I come to another part. This is the AIoT architecture. That means undoubtedly I have mentioned the layered architecture AIoT. Now the question comes that where the AI is going to be implemented. One solution is the centralized. That means the AI algorithms can be used only in the cloud. But that should not be an accepted one. So that's why what the people are using, the AI solutions are used at different levels. Okay, so it can be used in the cloud layer, it can be used in the edge or fog layer, it can be used in the AIoT device layer. That is basically mentioned in this diagram. So this is the hybrid AI deployment. So where the AI algorithm is going to be deployed. So hybrid solution is the most accepted solution. You can see on geographically distributed cloud nodes. In the cloud layer, some cloud nodes are there. So AI algorithm may run there. So it's specific algorithm. So another algorithm that demands small computation that may run at the edge or fog layer. So this is the hybrid AI deployment. AI deployment will be in various nodes based on various requirements within the architecture. And another question comes that whenever I am talking about the AI, this is very important. I would like to mention to all the participants that this could be a specific domain where you may contribute, because this is a domain that is not used that much, which is called the federated learning, because what should be the learning paradigm for this type of solutions. For the AIoT, the federated learning is used. But after going through the survey papers, that we have found that the federated learning is not that much used in context of the precision agriculture. And today's the federated learning, I'm just mentioning what's the advantage of using this federated learning. And this issue is called the learning paradigm. AI we should use, but what should be the learning paradigm? In most of the machine learning application, what we are expecting in the traditional way, the data from various organizations or devices are aggregated in a central server or a cloud platform for training the model. So where the training will be done? At cloud. This is a key limitation, especially when the training data set contains sensitive information. Just take these examples. Today, I am not going to deliver my lecture on the smart healthcare, but the peoples are delivering their lecture on smart healthcare. So this is an example on the smart healthcare. The hospitals may collect the data on breast cancer and collaboratively creates an efficient, robust learning model. But they should not want to share all this private data, because the data on the breast cancer for a specific hospital, they should not ready to share all this information. So in such cases, the private data transfer becomes a concern of security. So that means initially what we are expecting, that suppose maybe the 5-6 hospitals, they are working in a city, and they are collecting their data from their patients, and all of them are sharing the information, that means the data, towards the cloud. Now cloud train the model based on all this data. No, this is not possible. Security may be one of the reasons. So what should be the solution? The solution is the decentralized learning, or the federated learning, or the distributed learning. You know, the distributed machine learning is a machine learning technique that uses multiple computing resources to analyze large amounts of data. So what it means? It means we are not transferring the data. We are preparing the learning. Because I don't have that much of time, so I should not spend time in the distributed learning. I will share my slides, then I think it will be clear to you. I'm directly go to the federated learning. In the federated learning is the term that is basically coined by the Google in 2016. And what they're suggesting, what their objective, that multiple devices, just go through this and keep in mind, collaboratively learn a machine learning model without sharing their private data. Initially, just now what I mentioned, that suppose all the hospitals, they are collecting their private data regarding the breast cancer, they may not be ready to share all the information towards the cloud. And if cloud is not getting all the data, the learning model may not be effective. Then what should be the solution? The solution is that the multiple devices collaboratively learn a machine learning, but they are not sharing their private data. And this process is called the federated learning. So in federated learning, machine learning algorithm training is performed across multiple decentralized edge devices or servers, each holding local data samples. And not only that, now you can say that already I have mentioned one term, the distributed learning. So in the distributed learning, the major focus is on the distribute the data amongst more than one machines and try to execute the parallel processing. But in the federated learning, the focus is on a totally different issue. I mentioned here, this is called the heterogeneous data sets. That means one hospital is getting one type of data sets, another hospital may get another type of data sets. So that means the training model will be much more richer compared to the previous one. The same data, initially in case of the distributed learning, there is an assumption. The assumption is that this is called the local data sets are independent and identically distributed and roughly have the same size. But in the federated learning allow you that all the data sets, those are basically maintaining in the different sites. They are different in size, and they have the heterogeneous data. They are different in type. So that means this heterogeneous property is going to be embedded within the learning process, and we are not sharing the data. Instead of that, individually the learning model is executing in all these sites, and ultimately the summarized information is going to be transferred, and this is the process which is called the federated learning. So the federated learning becomes a typical issue that can be used for this specific domain, that is the AIoT, and specifically the AIoT, and maybe for the simultaneously for the precision agriculture also, because precision agriculture is also a AIoT. They are basically use the AIoT domain, and you can see as per the survey of the existing one, you can see that most of the cases they are using the existing one. They are using two layers. One is the edge, that is the edge cloud. You can see the edge cloud. Okay, edge fog cloud used in only work in 2020. So based on the application, they are choosing all these things. And there is one solution which is called the cloud-based. So based on some existing work, so this is a practical scenario from which you can feel that what I mentioned earlier, that these are the possible architecture, or this could be a standard architecture, but whenever the peoples are proposing the solution in context with problem, they are following the either EC or AC or CD or architecture. The communication technology, so I am not going to this because I would like to end within 5 minutes, 6 minutes. Okay. One thing is this. So another thing I would like to say. So all of we are today we are using another terminology which is called the cyber physical system. My question is, just now I have, if we can consider that already, I think I can communicate that what do you mean by the precision agriculture or what do you mean by the smart farming, and what are the possible smart farming problem. Is it considered as a cyber physical system? Because as per the today's, this is a specific jargon that we are using, the cyber physical system. Yes, it should be considered as a cyber physical system. Why? I am explaining the cyber physical system that through a totally different example. Then I would like to draw the analogy that why this is also called a cyber physical system. Okay, so this is another typical example. You can see, consider a team of autonomous mobile robots. Just try to visualize the problem. Task, what is the task of the robots? The identification and retrieval of a target inside a house, but the floor plan is not known to the robots. Again, I would like to repeat, some robots, they are within a room, they can move, they are autonomous mobile robots, but they don't have any floor plan, so they don't know where we should move, and their task is to identify and retrieval of a target inside the house or inside the room. So now each robot must be equipped with multiple sensors for collecting relevant information about the physical world. So that's why the cyber physical system means sensors, the cyber system and the physical system. Those are going to be blended. Those are going to be seamlessly integrated to propose a new unique solution. Okay, so each robot must be equipped with multiple sensors for collecting relevant information about the physical world. This is a communication between the physical to cyber. There are some onboard sensors. A GPS receiver is there to track a robot's location. A camera is there to take snapshots of its surrounds, and an infrared thermal sensor is there to detect the presence of humans. So all these are the IoT. These are, as per my AIoT layered solution, all these are at the data acquisition layers. Now, what is the computational task? Computational task is to construct a global map of the house, because until we can prepare the global map of the house, because the assumption is that the unknown floor plan, house with an unknown floor plan is not known to the robot. So my first task is to construct a global map of the house based on all the collected data. And this requires the robots to exchange information using wireless links in a coordinated fashion. That means all the robots, they are exchanging the information. Some connectivity protocol is needed. So within a small distance, they are transferring the data. So it could be ZigBee. You have to take the decisions. But this is the problem. And so that means at the device layer, just stop on the device layer, just try to remember that diagram just now I mentioned. The connectivity layer is there, just stop on the device layers. So within the connectivity layers, which protocol you are going to select, that should be your decision. So now the current knowledge of the position of the robots, obstacles and target then can be used to determine a motion plan for each of the robots. Now based on this, the motion plan of each of the robots need to be done. AI comes within the picture. You have to frame the algorithms. So such a motion plan includes high-level commands for each of the robots of the Ford. Move in the northwest direction at a constant speed of 5 miles per hour. This directive then needs to be translated to low-level control inputs. These are called the actuator for the motors controlling the robot's motion, because logically you can take the decision the robot should move in the northwest direction with this constant speed. But how it is going to be executed? So that now this actuator comes within the picture. This directive then needs to be translated to the low-level control inputs. That means again, the coordination between the cyber to physical needs to be done. That's why this is called the cyber physical systems. Okay, there are some additional design objectives, maybe the safe operation. But ultimately what I would like to say, that is the construction of the said multi-robot system to meet this objective requires design of strategies for control, computing and communication in a synergistic manner. This is the most important thing I would like to say, in an integrated manner. So the cyber system and the physical system, they are communicating among them, and in an integrated way, seamlessly they are working. So from this we can define, this is the definition of the cyber physical system. It may be required for you in many purposes. The CPS aim to perceive and understand changes in the physical environment. Please concentrate on this definition. Perceive and understand changes in the physical environment. That means robot can see, the robot can feel, take the data, exchange the information from other robots and understand the changes within the environment, analyze the impacts of such changes to their operation, and make intelligent decisions to respond to the changes by issuing commands to control physical objects in the system, thereby influencing the physical environment in an autonomous way. So this is the definition of the cyber physical system. And yes, this is true that precision agriculture is also considered as a CPS, because you can see this is the environment. This is the physical domain and this is the cyber domain. So between the cyber domain and physical domain, a seamless connection, a seamless data exchange is happening, and accordingly we are trying to achieve the target. So because it integrates physical agricultural processes with digital technologies like sensors, data analytics and communication networks to monitor and control farming operation in real time, essentially creating a closed loop. This is the term that they are using. This is the key term. Creating a closed loop system where physical actions are informed by real-time data analysis. So that's why the precision agriculture is also considered as a cyber physical system. So because maybe you are working on the cyber physical system, this is a very common term, the security with respect to the cyber physical systems. So you may consider the precision agriculture or the smart farming solution as a cyber physical system also. Now I am concluding my entire discussion with a very small example, such that you can perceive that what we would like to do actually. This is not at all a large work, but just for understandability, I would like to choose this type of small problem, such that you can feel that what we would like to solve through this smart farming or the smart irrigation system. You can see the smart irrigation system. This is a typical solution. That's why I mentioned a smart irrigation system. It's a work I have found from a specific paper. So what they are suggesting, they are Suggestion is to propose a cost-effective solution to promote smart agriculture that relies on open source and cheap commodity hardware. The solution uses own wireless sensors using cheap Arduino boards and use the fuzzy control unit using a Raspberry Pi card. So what is the objective? Objective one is to use the feedback fuzzy logic control for deciding on the irrigation duration. That means the water should be given, but for how much? Irrigation duration may be one decision parameter that should be decided by the solution that certainly saves water resources and lay the ground for better circumstances for plants growth. And objective two, okay, we should concentrate on the objective one because I don't have that much of time. I would like to conclude it. So go to the next slides. Now you can see this is the typical test bed. You can see this is the wireless sensors, the farmer data, the weather forecast. All these comes in form of a big data. So this typical module you can consider as a big data analytics platform. Okay. So within this, you can prepare the data, and this is your AIoT overall platform. You can see this is the control unit. From the big data analysis platform, the data may come to the control unit. This is the control unit is prepared using the Raspberry Pi. One actuator is there. Actuator means that converts the logical decisions to the physical one. So this is the pump one, this is the groundwater, and this is the pump two, this is the basin, and this is the irrigation system. So that means the task of the control unit is to analyze the data from the big data and accordingly either initiates the actuator one or the actuator two to take the decision, and to take the decision that how much time the water is going to be provided for the irrigation. Okay. And if the first thing that whether it is needed or not, if it is not needed, then pump the pool, then push the water within using the pump to the basin, such that the basin will be filled, and otherwise from the basin or from the pump water, just push the water towards the irrigation system for a specific duration. And this is the control unit 2. I am not discussing in this in detail, but in a single word, what you can say, this is the solar panel and this is the storage. So the electricity, if the electricity is off, then the solar panel electricity is going to be used from the solar panel. And if electricity is not required here, then it can be stored in the storage. So that should be a typical test bed, a typical irrigation system, a small irrigation system that we can conceptualize. Okay. And within this, these are the modules. I think now it's clear to you. You can feel that the WSN may be one module, wireless sensor network. Big data analytics platform could be another one. Wireless actuator network may be another one. So in that way, all these modules are there. Control unit 1, I just now mentioned. This is a component in a Raspberry Pi card. And the ways it runs algorithms on this Raspberry Pi that decide on whether to pump water from groundwater to basin via water pump 1. This is mentioned in this flowchart. I think this is visible. You can see the read actual soil moisture and temperature from BDAP. BDAP means that a big data module. And then take the decision. Actual soil moisture is less than desired soil moisture. This is called the SMD. If it is less than 0, if the actual soil moisture is less than desired soil moisture, then read actual water level of basin from BDAP. If the actual water level is less than 100, then start pumping water. That means pumping water is needed. Otherwise, calculate the duration of the irrigation from fuzzy logic control. So that's why one fuzzy logic box they are creating. From the real-time temperature, they are doing the fuzzification. From the fuzzification, they are using some rule-based like this inference engine, then defuzzification interface, and accordingly the duration of irrigation is going to be computed. You can see they are use the rules of irrigation. If the SMD value is less than 0, they are checking whether the SMD is less than 0 or not. So if the SMD is large negative, then the cold will be short, the normal and the hot will be very long. In that way, the fuzzy logic has been prepared, and that is embedded within this rule base. So that will be the typical solution. And you can see this is the actual solution. This is the groundwater. This is the basin. All the sensors are placed here. This is the solar system. And after execution of this, they are creating the test bed and they have implemented it. And they can see, you can see that based on this is a AUI smart irrigation. This is a graph with respect to the time and the temperature. So it shows the variation of the temperature in context with respect to time. You can see the temperature is varying from, this is 24, it's the maximum, and the minimum is this with respect to time. And this is the SMD, because that is another crucial input. SMD is one input, temperature is another input. So SMD is also varying, you can see, with respect to time. So that we have monitored, and accordingly the duration of irrigation is also changing, you can see from this diagram. And that's the purpose, that as these are the variables, so based on the time, when the SMD, that means already I have defined that what do you mean by the SMD. SMD is the difference between the actual soil moisture and the desired soil moisture. So if the moisture, based on the change in the ground moisture level, change in the temperature within the environment, the duration of the irrigation is going to be changed, and that is going to be prepared using some small solution, and that is working properly. So that could be a tiny example in context of this precision agriculture. So in a real world, it may be huge one, and as a result, a lot of challenges may come also. You can see there are some typical industrial solutions. I am going to share my slides to Dr. Suparna Bishwas. So you will get the slides. You can see these are the existing industrial solutions. And there are a lot of solutions are there with respect to the crop management, soil management, water management. But from this diagram, you can see the supply chain management. There is no such solution with respect to the supply chain management. So that means there is a chance that we can contribute something in context of the supply chain management. And these are some industrial solutions available. So this is the slide through which I am going to conclude my session. I am just now describing in detail a teeny example through which I believe that I can provide you, I can communicate that what do you mean by the smart farming, but what are the challenges in context of the real world. These are the challenges because first of all, instead of technology, there are some challenges because in context of the precision agricultural, this is still now not widely accepted. And there may be socio-economic reasons behind that. The farmers are not that much adaptive to adapt the technological changes. Cost could be one typical solutions. So that's why one challenge that we should address, that if it is possible to design more energy efficient sensor modes, because a lot of IoT devices we have to use within these solutions, and find cheaper and simpler solutions than existing solutions to recharge the batteries and use more intelligent solutions for scheduling and management of sensor modes. This is one challenge. Another challenge is that the security, undoubtedly it becomes a serious challenge because it will be the scenario that suppose I am a stakeholder, I am in my farm, I am going to implement something, I am not always ready to exchange all this data. Okay, so and if I am exchanging the data, initially I would like to ensure that my data will be secured. Otherwise, this solution may not be accepted by the stakeholders. That could be a serious task where we can contribute. So that's why the data security and privacy remains a serious challenge in this typical problem, as the security and privacy of sensitive spatial, temporal, and spectral information of crops is a serious concern of farmers. So nowadays, some solutions are coming with the blockchain tracing is starting to be used in SA. Ethical issue could be another issue, because whenever you are using the data of a stakeholder, you should communicate the stakeholder that we are using your data. This is one ethical issue. Oh, so the federated learning, because I mentioned that federated learning is a process through which, without exchanging the data in a different way, without exchanging the data, we can create in a collaborative way, we can create a large learning model. So FL could be a partial solution with respect to this ethical issue. We can convince them that, yes, I am taking your data, but I am not transferring the data. In your individual site, we are executing one learning model, and from the learning model, we are we are sending some parameters, some synopsis of your raw data is not going to be shared. So in that, in that case, the ethical issue can be solved partially. Robust encryption, authentication, and access control mechanism, already I mentioned, this could be a major issue. Scalability and reliability. Reliability is undoubtedly one major issue, because in the practical domain, what we can find that we are expecting that all the devices are working properly. They are providing me the data in a proper way, but due to some environmental changes, due to some other unwanted issues, that you are not getting you are not accepting the data. So that means your device should be reliable enough, such that maybe some in an environment or some in a weather condition, based on weather conditions, some of the devices may not be working properly. So we should use that type of devices such that these are robust, and it should be reliable. And reliability, undoubtedly an issue. Scalability, because you are using a lot of devices, and whenever the number of devices are increased in that range, comes to that range, then the problem of scalability generates. So that is another concern, that how a scalable problem is going to be proposed. And another thing is that, because if you have experience, because I have some experience to work in the smart healthcare, in that case also, whenever we are using this type of devices and we are try to integrate all this data, we are facing the problem which is called the problem regarding the interoperability. This is true for this case also, because they are generating some data, these are heterogeneous in nature. So that means different formats, different time granularity, precision. But your challenge is that you have to integrate and you have to create a synopsis data such that all the data that you are generating using different IoT devices, you are gathering all this data, and you can solve the problem of the interoperability. You can generate a synopsis data from the existing raw data. So this could be another typical issue, that how this interoperability can be overcome. And another major problem is that in the paper that they have mentioned, that for the validation, till date, there is no such standard data sets. Some of the people are downloading the data sets from the Kaggle and they are working. Some of them, they are creating their own data sets, but the data sets need to be open for testing and training. Agricultural system, to complicate things, equipment suppliers and farm operators alike may be reluctant to open their data, as it could reveal trade secrets. So that's why a major challenge facing the real deployment of SA is the lack of integrated and open data set for research and deployment. So these are the issues. I'm not going to extend that much, but these are the issues through which a robust smart farming solution can be generated. Already some of the solutions are there, but a lot of scopes are there where we can contribute. So my objective is that within this 1.5 hours, I am trying to, because I am also learning during the last few days, I'm just going through all these papers and try to jot down the information in a single slides. And I believe that it could be a good preliminary draft for you if you would like to work in this precision agricultural domain, because I am trying my best to mention what are the prerequisites, what are that means the AIoT, and what do you mean by the CPS, what are the problems that you are facing till now, what are the spaces where we can contribute in context of the smart farming or the precision agriculture. And through this, I am going to conclude today's session and thank all the participants. Even if today, just after the Saraswati Puja, I believe that all of you may be busy, but still a lot of people are attending my lecture. I'm really astonished. But okay, thanks to all of you for the patience hearing. Thank you. Thanks all of you again.
Thank you so much, sir, for this, what to say, a 360-degree overview and addressing the challenges, the scope of works in different aspects of precision agriculture, and some of the tools and techniques or the specific technologies that we may need to learn and apply if we wish to continue or begin with the research work in this emerging area. And if anyone of us, or maybe many of us, are already in this domain, so they also can find the connection with this so much of elaborative, illuminating and exploratory session of Professor Shankhan Chaudhary, sir. Thank you so much, sir, for this wonderful session. And sir, now
সুপর্ণা, আমার ব্যাটারিটা বোধহয় মেশিনের একদম লো হয়ে গেছে।
হ্যাঁ স্যার, সেটাই দেখুন। Yes, sir. So can we go for a short interaction, any one or two, because the next speaker of next session is already waiting.
Then I think you can start. If you have a question, then you can send me the question. I will provide the answer. And I am sharing my slides to you. Please.
Yes, sir. Yes, sir. That would be very useful.
Otherwise,
please,
anytime my machine will be off.
Yes, sir. Yes, sir. Okay. Thank you so much, sir. We extend our heartfelt thanks and to you, sir, on behalf of the.
Thanks to all the participants. Again, thanks to all the participants.
Yes. And once the slides are received, will be shared with you.
Okay.
Yeah.
Thanks.
Thank you so much, sir.
So may I leave, Suparna? Yes.
Yes, sir. Yes, sir.
Okay. Thank you.
So, thanks to all participants for your patient hearing, and there are so many takeaways as a beginning lecture, and nothing could be better than this, because this is really giving you the very preliminary prerequisites, as also sir mentioned, and what are the issues, what are the challenges, what are the different sectors of research in the overall precision agriculture. That detailed view has already been provided to us, so that we can choose our own while we traverse through the coming days of this FDP. So thank you so much all. And now our distinguished speaker of next section is already with us. Yes, sir. Ovijit, sir, you are with us, sir. You have joined already.
Yes, hi, Dr. Suparna, I'm here.
Okay. So we are just going to start the second session. These two are back-to-back sessions, so there is no scope of break. Of course, the challenge that we all follow while we work in the domain of healthcare, that about the data collection. Yeah. And we have we have this opportunity to interact with Dr. Ovijit Kumar, who is from this medical fraternity, and he will obviously put some light on us, on the researchers who are at the technical part, that how to cope up with this challenge of getting data, the actual data. There are so many data publicly available in different sites, like sir has mentioned, the Kaggle is there, UCI public data set is there. There's so many other publicly available data, but that are benchmark data sets. But if I want to start a new research and if I want to collect health data, then there are various challenges. So sir, I would request you to address this issue amongst the others that you have planned for this session. So while we start the session, there is a brief introduction of Dr. Abhijit Kumar, the anesthesiologist and assistant professor in the Department of Anesthesiology, AIIMS Kollani, West Bengal, India. Dr. Abhijit Kumar is an accomplished anesthesiologist and assistant professor in the Department of Anesthesiology at AIIMS Kollani, holding multiple prestigious academic degrees, including MD, DNB, MNMS, EDAIC, IDRA, CCPC, and FCCS. He specializes in artificial intelligence applications in anesthesiology, difficult airway management, labor analgesia, and research methodology and statistics. A recipient of the ISA Young Talent and Young Anesthesiologist Awards, he also serves as the honorary treasurer of ISA and is a founding member of Seamless Statistics. With 21 publications in national and international index journals and contributions to 6 book chapters, Dr. Kumar continues to make significant contributions to the AI-enabled healthcare field. So we are having back-to-back sessions, one on precision agricultural issues and another on smart healthcare with the AI applications. And nothing could be better than this, that we are getting a person from the medical field, active medical field, direct medical field, who will put light on this research domain. So session is over to Dr. Abhijit Kumar.
Thank you so much, Dr. Suparna and Dr. Sohail. Thank you for inviting me, and let me share my presentation. I hope it's visible now.
Yes, yes.
Yes,
Yes. Yeah, please make it full screen. Yes.
I'll do that. All right. So once again, thank you, Department of CAC and Computer Applications of MAKAUT, for inviting me. And once again, thank you so much, Dr. Sohail and Dr. Suparna, for inviting me, and my dear friend Ayan, who is an assistant professor in MAKAUT itself. Thank you so much. As you can see, the talk is on AI invasion in critical healthcare system, doctor's perspective.
Can you please make it full screen? Your presentation actually, can you go it in presentation mode?
I think I have done it. Let me do once again. I'll just stop sharing and I'll reshare once again. Okay.
Yes, you can press your F5 from your keyboard also, or that will make it full screen.
Is it now?
No, it's not showing in.
Yeah, so I think I have to stop the presentation.
Reshare, and please reshare in the full entire screen. Yeah, that will work, I guess.
Is it visible in the full screen now or still not?
No, it's in slideshow. Please go to the slideshow, slideshow button. In that, yes, slideshow tab, and from beginning, yes.
Does this solve the purpose?
No, not now. No. So if you click on from beginning, is it anything happening there? Yeah, it's now fine.
Okay, all right. So, as healthcare professionals, we have to spend countless hours with our patients, diagnosing, treating, and caring for patients. And those treatment and diagnosing based, so far, it's based on our cognitive capabilities and motor skills. But at times, we feel like we should have some dynamic assistant who would help us with the current data, or we kind of try to fit our evidence into the patient rather than practicing customized care for a patient, or what we call these days a precision medicine. So we are in the brink of an era of artificial intelligence, where it is not just a concept, it's we are using it on a daily basis. So what are the transformational journey that we are applicating on our daily basis, transforming the traditional healthcare to a AI based healthcare approach, which is patient friendly. But there are certain challenges, pros and cons are the part of it. Are they reliable? Are our patients who are actual benefactors, they are ready to be helped with AI equipped medical tools? So in this presentation, I'm going to take you through the applications of AI which are being implemented in healthcare delivery sector. And along with that, I'll be going less on the technical aspects, as you guys are specialists on that, and some of the challenges that we are facing right now on applications of AI in medical system. So my presentation will be comprising of pictures and tables, and anything on dark maroon red will be very important. Bold is also important. So there might be some busy slides, so kindly cope up with me. I know the attention span of us is going down, but please be attentive. If you have any questions, feel free to drop your question in the chat box. In 2023, Mr. Zuckerberg has launched a Chan Zuckerberg Institute, where he aims to eradicate all the disease by the year 2100. And he quoted on that ceremony that AI will enable doctors to diagnose disease and treat people better. So there are innovations of applications of AI, but he said that so blocking that progress is probably one of the worst thing you can do instead of making world better. So with this pretext, the objectives of my talk is I'll be touching upon the AI terminologies applicable to healthcare, mainly on applications of AI in healthcare, important software and AI tools, some of the evidence base of AI-based applications. Yes, I cannot skip AI tools being used for medical research. Although my domain of my talk is not about the market size and CAGR of healthcare industry based on AI, but still I'll be talking a bit on that. And lastly, the ground reality and the challenges that we are currently facing. My previous speaker has mentioned the challenges as well. The concept of federated learning and the CSPs are being very useful in our currently our healthcare sector. So I have a preset model of my presentation. I start with the definitions, but Dr. R. Bellman in 1978 coined the term, the study of algorithms that gives machines the ability to reason and perform functions such as problem solving, object word recognition, inference of world states, and decision making. That's machine learning. And this is the second ritual that I do before my presentation. I was surprised to see the number of papers that was there on artificial intelligence and healthcare. This is the major search engine that we consult while doing a research, PubMed. And just look at the presentation papers that are coming in last couple of years. They are booming, and in upcoming years, they are set to becoming more and more. So what are the prominent AI technologies that we are being used in healthcare? This list is not exclusive. It starts from machine learning, goes through deep learning, neural network, NLPs, computer vision, RPAs, generative AI. Although fuzzy logic, support vector machines, and Bayesian methods are old, but they're also increasingly used in healthcare. While going through, I was kind of trying to understand the relationship between AI, ML, deep learning, and NLPs. As you can see from the diagram itself, AI is a broad field that includes anything related to making machines smart. NLP is a branch of AI, and ML is a subset of AI, and DL eventually is deep learning is a subset of ML that uses models built upon deep neural networks to detect patterns of with minimal human involvement. So these are the tables where I try to summarize for my better understanding so that I can deliver it in a better way, how machine learning and deep learning are being useful in healthcare. So machine learning is a subset of AI. I should not say without being explicitly programmed, but yeah, it is less computational. It has less computational requirement than deep learning. The assumptions are machine learning requires structured healthcare data. That means structured patient records, like there is a system called CDAC, or there are particular system called PACS system or HMI system. They have a way to document the patient data. So machine learning needs that kind of structured healthcare data, and to identify, to do manual feature extraction, like identifying risk factors. On the other hand, deep learning can learn from raw medical data, like patient notes, MRI scans, and it can perform automatic feature extraction, like detecting abnormalities. So users, they are, although it will come later in my presentation, but predicting patient outcome, patient triage in emergency, these are machine learning can be very useful. I'll be showing you some papers on these as well. Optimizing hospital workflows, identifying high-risk patients who need specialized care can be done by machine learning. On the other side, medical image analysis with convolutional neural networks for detecting tumors, predicting disease progressions, and real-time patient monitoring is of the purview of deep learning. So I am from the field of anesthesiology, and this is a paper which was published last year in Anesthesiology Journal itself, which actually illustratively depicted, showed that a 3-layer neural network to predict the depth of anesthesia, whether the patient is awake or asleep during anesthesia. On the left-hand side, you can see that the input layer consists of electroencephalogram, basically reading of brain waves, EEG entropy, mean arterial pressure, and heart rate variations. And then there is a hidden layer that, and finally the output layer. These are although basic neural networks from a doctor's perspective, but still these seems to, like, these are kind of alien to us. So that, and the fact is they are not transparent to us, becomes a challenge to us. We don't know how this works. So as a doctor, for accepting these modalities, it is very important that the system should be transparent enough so that we can see what is happening and we can understand what are the specific inputs and output that we'll be getting from a system. NLPs and LLMs are also being increasingly used in healthcare. NLP being used in analyzing patient records, automating medical documentation, supporting virtual health assistants, and extracting information from clinical notes. Whereas LLMs, we are commonly using these days, are providing insights from literature and data and aiding in diagnosis. They are also used for generating synthetic medical images for training as well. I'm not going into the techniques. I'm sure you all know. Computer vision and machine vision is also being used. They aid in diagnosis and treatment planning as well. And machine vision helps in quality control and robotic assistance in medical procedures. So the key technologies for computer vision is CNNs and image processing techniques. On the other hand, machine vision, it has a high resolution medical imaging system with sensors and image processing softwares. As you can see on the bottom, the use case examples are very promising. Detecting early signs of retinopathy is one of them, which utilizes computer vision, analyzing MRI scans for brain abnormalities, enhancing surgical precisions with AR, augmented reality. And on the other hand, machine vision is very useful in inspecting medical devices for defects. It helps in guiding surgical robots during surgeries, and it enhances the precision in assembly of medical equipment. Support vector machines and fuzzy logics are also used for either classification and regression tasks. And fuzzy logic is specifically useful where Boolean logic fails, and they're better in while handling uncertainties and imprecisions. They are applicable in disease diagnosis, prognostication, and prediction of disease outcomes. When a patient comes to us and we are being frequently asked, what are the chances of survival? What are the chances of getting better? What are the chances of getting discharged? We give them the numbers based on our research papers and the literature that is there with us. Or if you have an SOP from the hospital, we give them. But if we have a real-time AI-based model where we can fit in the patient data and demographics, and it is fairly reliable, then it can give us an approximation which is kind of transparent to the patient's relatives and us as well. So at these junctures, these are very important. And fuzzy logic is also important for medical diagnosis, patient monitoring, risk evaluation. Support vector machines can be useful in predicting diabetes, pre-diabetes, and enhancing disease forecasting. Bayesian methods, these are based on Bayes' theorem and particularly useful in personalized medicine, predictive modeling of particular disease sets, and they are useful in particularly clinical trials where we continuously develop data and we incorporate those data and further modify our trial so that the output is optimum, that the application of those trials become more patient friendly. Robotic process automation is also being used specifically for those monotonous tasks like patient data management, inventory tracking. Although as doctors and healthcare workers, we work with the patients, but a hell lot of backdoor job happens in the hospitals, like storing the patient data, storing the inventory, getting the new medicines and equipments in the hospital, as well as cleaning the used drugs and equipments. These all can be done with robotic process automation. Medical documentation and automated reminders can be also done with these RPA techniques. Gen AI is a new thing, is being increasingly applied, and all these things like healthcare task automation, from administrative tasks to insurance claims, personalized treatment plans, training and simulation, drug discovery development, predicting outbreaks, and virtual health assistance. Gen AI can be useful in all these aspects. So when we talk about applications of AI and robotics, let's take an example that we all are sitting at home, we are healthy, we are well. So if we want to track our health, how well we are keeping up, so that can also be done with AI. And as we progress in the spectrum from healthy to becoming diseased, early detection, diagnosis, decision-making, treatment can also be done using AI and robotics. So this is not only AI's job, this is AI helping doctors to diagnose the condition efficiently, and that saves time, that enables patient to get early treatment. If the treatment is not successful, we cannot save everyone. At times we have to deliver end-of-life care, which is very challenging. We know that the patient is going to die, but our target is to soothe them in as much as possible, to make their life as comfortable as possible till the time they're there. So even AI is being increasingly used in end-of-life care, and nonetheless, research and training AI is being regularly used. I'm going to take up all these in upcoming slides, and I'm going to discuss about the challenges as well. So applications of AI in critical healthcare, as I said previously, assisted diagnosis, making, and prescription. It is not only about just checking the artificial intelligence system about the diagnosis. It's about aiding the diagnosis and coming to the diagnosis in an efficient way so that we can cut down on workup time. Workup time at times takes weeks for a patient who's suffering from a rare disease. So from common to rare disease, we can use AI in diagnosis and prescription making. Medical imaging and diagnosis, AI is being increasingly used to analyze medical images, and they are assisting radiologists to make accurate diagnosis. Predictive analytics is a big thing which is happening right now in healthcare. As I said previously, we need to predict those patients which are going to get into that high risk zone, who all are more likely to get severe disease, who all have more likelihood of readmission and deterioration, and which will enable us to take proactive intervention so that those things can be avoided. And personalized treatment plan generation is also under this purview. Robotic surgery is happening, and AI is making our robots better. So AI-driven robotic systems assist surgeons to perform precise and minimally invasive surgeries. Remote patient monitoring. In India, doctor-patient ratio is still not in the green zone. So as a doctor, I have to cater to, particularly as an intensivist and anesthesiologist, I have to cater my patients in operation theater, in ICU, in OPD, in pain management wards, multiple locations. I cannot be there all the time. So remote patient monitoring is useful in those situations where with an interface, I can remotely monitor all my patients in one window. Clinical decision support system is a real-time support to clinicians by which offer evidence-based recommendations and alert on specifically on inpatients, but yeah, it is being worked on outpatients as well. AI is being increasingly used in drug discovery and development, and other overall healthcare management like hospital operations, scheduling appointment, resource allocation, and inventory management is also being increasingly smart with the applications of AI in healthcare. Virtual health assistants are being are big time in with the help of artificial intelligence, with information, reminders, support to patients, improving patient engagement and adherence to treatment plans. So these are two prominent AI-based application platforms, Google DeepMind and IBM's Watson for oncology. They are working on multiple health problems. One of the most common ones is detecting diabetic retinopathy in India, which is the Google DeepMind's initiative. I'm going to talk about that in my next slides. Yes, robots are also being integrated with AI, and they are becoming smart. So as you can see, Casper is a child-sized humanoid robot designed to help teachers and parents to support children with autism. The Giraffe is also a mobile communication robot that facilitates chronically ill patients, and they contact with the outside world with these kind of modalities. And in future, India is also going to get more geriatric patients, but these kind of mobile communication robots can be very handy, and they are remote controlled, they are on wheels and has a camera and monitor. A VBot is a robot that can draw blood faster and more safely than human. That is debatable statement, I know, but yeah, they are being developed. Toyota has created 4 robots to enable immobilized patient to walk and balance on their own. So these are the pictures right from the top. Casper standing beside sitting beside the laptop. Then we have Giraffe. As you can see the screen. On the right hand side, we have Toyota, and on the lower side, we have VBot, which is an automatic blood collection robot. So AI-based surgical robots are also in. There are multiple robots are being developed. There is recently a transatlantic surgery which happened. The Verb Surgical, working with Johnson & Johnson, is developing a new generation of surgical robot with incorporating advanced visualization and machine learning. Major Robotic Renaissance is also one more, and Transenterix. These are all medical device companies pioneering in the use of robotics to improve minimally invasive surgery. So this is the prototype Da Vinci robot performing a robot-assisted surgery. You cannot see the surgeon here. Surgeon is sitting somewhere else on the console and operating on the patient. These are all possible today because of increasing use of analytics using AI. So AI-based robots, as I said, is useful in end-of-life care as well in the form of parotherapeutic robots, Robot Era and Zora robotics. This is basically to soothe the patients, to communicate. They actually perceive the emotional feedback from patients and behave in a certain way which provides comfort to patients. The left one is Paro and the right one is Zora. Yes, AI-based wearables are a big in these days. I'm sure we have a talk on smart healthcare in days to come. So I'm going to touch briefly on the LumoFit, which is a posture monitoring device that alerts a person when their posture changes, thus providing feedback necessary to ensure correct posture when sitting and standing. Under Armour, which uses IBM Watson Sprout, is the cognitive coaching system in an application that provides customized advice for sleep, fitness, activity, and nutrition. There are other wearables as well, like a vest, which can screen detection of breast cancer. Cardio Diagnostics has developed a device that is able to remotely monitor the wearer's heart irregularities and used to improve cardiac monitoring and rhythm management. Pathway Genomics is developing an application that will help, or that will provide customers health advice based on specific genetic makeup. So this is also being worked in Western countries, that they're developing a genetic database of the entire population, so that the molecular, the genetic basis of particular disease can be identified, and those particular patients can be notified that they are having increased chances of suffering from those kind of diseases, and they can take preventive measures. So we have talked about AI applications and AI tools, surgical robots, but are they reliable? And what are the evidence behind them? So while searching through the literature, there are plenty of literature available like this. This is a clinical decision support system, a paper on CDSS, which was published in Critical Care in 2023. And the researchers on this paper, they concluded that AI is here to stay. It will permeate the practice of critical care and has immense potential to support clinical decision making. But they have highlighted that with this benefit, it brings along deep ethical, fairness, and governance issues that must be addressed in a timely fashion. But in certain, it's not all gray. In certain papers, it is of definite benefit, like specifically of image analysis. As I showed, this is a paper where applications of artificial intelligence in emergency and critical care diagnostics, which actually worked on MRI images and histopath images to diagnose malignancies. And this is the SROC curve, which showed that the system, that the model they have trained was highly sensitive and specific than the clinician itself. The system had more than 90% sensitivity and specificity, where the clinician could detect with a sensitivity specificity of 80 to 90%. Yes, AI-powered predictive analytics are revolutionizing clinical practice. They can sense the insulin activity charts, they can sense the heart rate variability, and they can predict the incidence of adverse outcomes, and we can take necessary steps, and overall patient benefit can be enhanced. So this is another paper which showed the deep learning in disease prediction. So this is a schematic presentation starting with extraction of DNA and RNA followed by sequencing. So when we talk about DNA sequencing, it is easier, but to predict from those DNA sequence whether the patient is having what kind of mutation takes time. So this diagram, as you can see, is following a sequencing, and subsequent genetic alignment is performed during neural network and deep learning. The probability calculations are achieved through applying statistical models. And in this graph, you can see that gene deletions certain gene deletions are there in certain age groups and patients, which shows higher probability of depression and hypertension, whereas added gene mutation has higher probability of getting Alzheimer's and breast cancer. AI is being increasingly used in radiation oncology and surgical planning as well. Planning a radiation is time consuming, and that is the reason there is so much waiting time for radiation for patients who are yet to receive radiation for their malignancies. So for doing a plan, for effective planning, radiation oncologist has to see all the MRI or CT scan images. They have to manually draw all those tumors and put them together into the system so that the final planning can be made. With the help of AI, those things can be done within a very short span of time, and that will significantly reduce our patient waiting time. So these are certain examples of in augmenting our efficiency with AI. As you can see, the quantitative radiology, radiation oncology, and surgical planning with inner eye deep learning toolkit can include quantitative radiology for monitoring tumor progression and planning of surgery and radiotherapy. They can be very useful if they are proven to be reliable in our clinical practice. Nonetheless, Google DeepMind has powered a site called AlphaFold. They actually predict the tertiary and quaternary protein structure. So as I have previously mentioned, that protein sequencing is easy, but the characteristics of those proteins, they depend on their structure, their primary, secondary, tertiary, and quaternary structure. So through a technique called multiple sequence alignment, they can use deep learning pathways, and they can effectively predict their 3D structures. And this is a kind of repository of all the 3D structures you can find of all known proteins of this world. I was talking about diagnosing diabetic retinopathy with AI. Google DeepMind has begun working on this project in 2016, and automated retinal disease assessment is very much in practice in India. Mainly on the southern parts, they are being developed continuously, where an optometrist goes to field and clicks the photograph of patient retina, and it automates the detection of diabetic retinopathy, which is the leading cause of blindness in our country. Infection and severe infection, what we call as severe sepsis, these are also being predicted with an algorithm. The patient survival and hospital length of stay can be predicted with the machine learning algorithms. This is a paper on RCT, which was published on BMJ, which showed that with the help of applicating those machine learning algorithms, we can effectively reduce the length of hospital stay and ICU stay for those patients, as well as those machine learning techniques. They can predict the in-hospital mortality rate as well. So when the patient is admitted in an ICU in a critical condition, and we have to quote a number, and we have to take necessary measures, these machine learning toolkits will be very useful in days to come. Although this is a first landmark paper, there's more work happening on this ground. Not only about doctors, the nursing care is also being increasingly influenced by applications of AI. My aunt was a nurse. I remember she was not very happy when government introduced computers in the hospital. She said that we are being overloaded with extra work, so that we have to work in computer as well. And now our nurses is also saying the same thing when the AI is being implemented. So this paper concluded that while nurses acknowledge that AI's potential to streamline workflows and improve data analysis, but the concerns rose regarding workload and information overload. But yes, we have to make the system easy so that already overloaded system should not get more burden with additional workload of AI being implemented in the system. So we need to make AI systems easy and less time consuming to be efficient in our country, specifically in government healthcare sector, where getting a bed, getting a patient proper medication is difficult, and we are talking about AI. So we need to make these AI systems efficient so that it does not overload our working workforce. As an anesthesiologist, I could not help but to include this slide. Applications of AI in the field of anesthesiology, as I've already mentioned, it is being increasingly used in depth of anesthesia monitoring, event and risk prediction inside operation theater and ICU. These are implemented in ultrasound guidance while we do ultrasound guided procedures. These are increasingly used. They are used in personalized pain management approaches. Specifically in OR logistics, it is being increasingly used because even in busy hospitals, scheduling a surgery and resource allocation is a big challenge, and AI is helping in big time in operation room logistics, and control of mechanical ventilation and weaning is also becoming increasingly easy with the help of artificial intelligence. Mental health is also one point which I felt needs to be discussed here. AI-powered chatbots provide accessible support through conversations. Predictive analytics, including using AI, can predict mental health crisis and suicidal tendencies. There are certain mood tracking apps which help users to track their emotional well-being. Virtual reality therapies are there already for specifically patients of PTSD and anxiety. The social media monitoring can also be done for signs of mental health issues. As I previously mentioned, genetic analysis, which analyzes genetic data to identify predispositions to mental health conditions, are being increasingly used, which aid us with early diagnosis and personalized treatment. Medical research, yes, AI is being increasingly used. Literature review tool as literature review tools, as data analysis tools, as writing and editing tools. Literature search is being increasingly integrated with artificial intelligence. Summarization apps are also in place. Research management tools. If you have not visited this website, Nature Research Intelligence, please visit that wonderful website, which help manage research projects by categorizing documents and tracking research projects. So the applicability and the benefit of GPTs in research, there are multiple research papers, and all of them have mentioned that GPTs are very useful while we are specifically doing a research. And this is the paper I want to highlight, which mentions the GPT utility in healthcare education research and practice, systematic review on the promising and prospective and valid concerns, which specifically highlights that while academic and scientific writing, these GPTs are they are very useful, and the benefit of science research is also highlighted. But at the same time, the same research article have raised the risk and concerns of GPT in healthcare setting. I have used GPT and the Copilot both while doing my scientific writing, but there are ethical issues. There are a lot of bias, plagiarism, and risk of incorrectness and accurate information are there. You need to be very thorough in your checks. They can, rearrange your write-up, but they cannot generate, as of now, authentic scientific writing. So transparency issues and reference inaccuracies are there. There are chances of over-detailed content being pushed more and more in the scientific writing by the use of these GPTs. So there are copyright issues as well. So to circumvent that, recently more and more research paper is they're coming where it is mostly on use of these LLMs and ethics, their ethical consideration, their transparency, and their other issues. So this is a landmark paper published in Neuroscience, and they have basically asked ChatGPT the same question on authorship, and the reply was in the line, which I did as well. As a language model, ChatGPT said that I do not have the ability to consent to co-author a research manuscript. However, I can provide assistance. Some of the journals are already accepting ChatGPT as the co-author, but ChatGPT has not given the permission from his side or her side. So I did the same thing. I asked ChatGPT, please explain how ChatGPT is a friend in research. And it has given a clear mandate that, however, it is important to note that while ChatGPT can be a valuable tool in research, it is not a substitute for human expertise and judgment. Researchers should use it as a complement, to their own knowledge and critical thinking, and be aware of its limitation, such as potential biases and inaccuracies. I asked Copilot at the same thing, and it has also kind of told me the similar thing, that it can provide information, insight in writing process, and cannot be a sole author. So best research AI tools, some of them are there: PaperPal, Grammarly, NVivo, Litmaps, Semantic Scholar. All of them can be very useful while you are doing your research and writing down your paper. And personally, I use them increasingly, being a biostat enthusiast. My personal favorite is Julius, although ChatGPT, Data Lab, H2AI, and Data Robot, they can be very useful when you are doing a statistical analysis of your data. With this backdrop, I'm going to come to the challenges that we as doctors face while implementing AI and documenting data for AI. But let's look at the market size and the CAGR of AI in healthcare market. So 2023, it was kind of $20 billion. 2024, the global market size is somewhere around $27-28 billion, which is projected to reach around $200 billion in 2030. US is the largest player with the CAGR of 35.8%, and India is taking baby steps with 750 million USDs in 2023, which is supposed to touch $8 billion in 2030, but the CAGR is one of the highest. It has passed 40%. So increasingly, the investment is also pouring in this sector. So the doctors are implementing AI. The funding has increased. Are the patients ready? So this is a PwC survey where respondents all across the globe, they asked whether they're willing or unwilling to engage with AI and robotics for their healthcare needs. So as you can see, most of them said they are willing. 54% they said they are willing, and 7% were indecisive. But when I went through that survey, you can see the 9% mark. So as the invasiveness of the treatment increases, the respondents, they become increasingly averse to AI. So when it comes to monitor the condition of your heart, pulse, BP, provides customized feedback on your health, then people are relying on AI. But when it comes to even a stitching or a bandaging, even minor cut, or you progress from that to major invasive surgeries, people are not relying on AI. So still, AI in healthcare has way to go in terms of patient acceptance. Now, the main factor is the challenges that we face for AI in healthcare. First and foremost thing, yes, I'm sorry to say that, but being a government employee, there are still lack of interest of policymakers to integrate, because there are other challenges, because the doctor-patient ratio is still not adequate. Patients are not getting bed. In rural sectors, patients are not even getting proper treatment. Still, mothers are delivering at home. So at this point, integrating AI to healthcare might be a far-fetched idea, but we should not stop as the development goes forward. We should not stop doing anything. There is a lack of policymakers because it is time-consuming. It is financially draining to our governments, but it will come. My opinion, it is going to come. There is a lack of data and inability to function without data. So I feel there is a lot of data is there, but they are not being documented into a legible format. So the non-availability of clean data is the biggest challenge to apply those machine learning algorithms in healthcare. So we still documenting data by hand, and to store them into a legible electronic format is still time consuming. We are not well versed with it. The majority of us are not well versed with it. India has huge potential, and we are generating tons and tons of data, but still we are not able to document them electronically, and that's the reason it is not being available to our data scientists and researchers. Yes, there is a risk of bias and lack of reliability. So then that is the reason that there is a lack of trust in clinicians. So as the term says, it's kind of a black box AI. So the trust builds on a transparency. So we cannot see how AI is actually working. And that is why the reliability and trust issues come into the picture. So to design an effective AI model which is applicable to wider healthcare network, it needs to be transparent, it needs to be easy, it needs to be patient and doctor friendly. Well, there are not adequate research and inadequate awareness among clinicians as well. We talk about evidence-based pyramid, and so far systematic reviews and meta-analysis, they are on the top of those evidence-based pyramid. On AI and healthcare, we don't have that amount of robust research. We need to generate and do more research. There are ethical and regulatory issues. There are cybersecurity and data breach issues. I'm sure our data scientists and engineers are working hard on it. And there are still inadequate infrastructure. The hospital I am working in currently, most of the time the beds are full. So the major challenge is to accommodate more patients to our hospital. And although we plan to increase our kind of cloud storages, our software, our CDAC, our HMIs part also, but we are mainly focused on increasing our bed number. So once we can increase those, then we can work on these part which is not directly related to our healthcare. Most importantly, medical legal implication. There is a lot of study happening in US and Canada on medical legal implication of AI. Suppose the AI interface asks me to diagnose for a certain condition, which I feel is not, as a doctor, I feel is not appropriate. And believing the system, I have kind of accepted the diagnosis and written a medication on that ground, and patient land up into some kind of complication. Who is going to take that medical legal responsibility? The court says the responsibility still goes to doctor, because doctor is prescribing the prescription, and the patient is taking those prescriptions. So there is a huge gray area on medical legal implications of AI in healthcare sector. So that needs to be addressed properly as well. So this is a schematic diagram which showing the factors influencing trust in artificial intelligence. So those are the factors. You can see the complex algorithm, data sensitivity, cognitive bias, lack of subject knowledge, and role of artificial intelligence. These are the factors, and the possible ways it can improve the trust on artificial intelligence is by increasing transparency, ensuring robustness, and encouraging fairness. With these three, we can increase the trust and capability, and the optimal delivery of health outcomes can reach our end user, just that is the patients. What should be done to overcome these challenges? Stakeholders, yes, all the stakeholders, all these institutions, maybe medical institution, engineering institutes, and other management institutes, the stakeholders should come together to ensure AI in healthcare is ethical, is responsible, and equitable, resulting in improved outcome for all. The stakeholder from all across the healthcare, government, and beyond must ensure that algorithms are developed and work responsibly and transparently. Yes, data privacy is a big concern. Government must strengthen those data privacy laws and regulating the use of anonymized patient data to train algorithms. There is a term called de-identification, which is being increasingly used specifically when we are recording healthcare data, which contains patient's identity. So if the de-identification can be easier, where we can remove patient's name, patient's gender, patient's address from the medical data, it can be a very, very helpful. So that data is basically a gold for us, where we can build up our AI models. Data ownership is also, as I discussed, they must also help codify data ownership and security policies to encourage interoperability of data across the border and corporate worlds. So, as my previous speaker said, the federated learning. So, we are storing the data in our hospital. Let's imagine we have developed a system which will efficiently record the medical data and store it in our servers. We are not sending the raw data outside our institute. We are asking models or other data scientists to come to our system, run their models, and so that we can come to some form of conclusion and build upon that. The governments also incentivize investment from private and private in AI and allocate funds to scale up these solutions that are already working elsewhere. And this is how you can improve, interested parties to come to our institutes and work together. Partnerships is important between countries, between institutions, between colleagues. Must also be cultivated to ensure AI innovations are accessible all across borders, especially when it comes to low and middle income countries. So this is a kind of illustrative multi-step approach to build effective and reliable AI augmented systems in healthcare. Yeah. So the first thing is to design and develop. We need to identify the right problem, the scalability of the problem as well. The stakeholder engagement needs to be there. We need to understand the context and the clinical workflow. Ethical implication and implication should not be ignored. Then comes the step of evaluation and validation. Then comes the picture, the statistical validity comes to the picture. That we need to define the failure modes, the clinical utility, and most importantly, the economic utility of those models. After that, we can just diffuse that system and scale that system in the form of development of the modality, regulatory approvals, model updates, reimbursement, and payments if necessary. And finally, we need to monitor and maintain those models in the form of post-market surveillance, safety monitoring, and prospective performance. So with this, we've almost come to my end of my presentation. Artificial intelligence has the potential to impact all aspects of our healthcare, ranging from disease prediction, precision medicine, till end-of-life care. As research advances, technology development intensifies, AI will be crucial for practicing clinicians in near future. But clinical practice-based insights will assist data scientists to integrate AI with healthcare in a holistic way. But we need to do the AI integration responsibly, which requires collaboration between healthcare professionals, data scientists, and most importantly, policymakers. We need to convince our policymakers that this is going to stay. There is no way we're going to skip from this. And in the long-term basis, the AI is going to help us. So with this, I would like to quote the famous neuroscientist from Johns Hopkins, Dr. Benjamin Well. He said, AI will not replace doctors. I'm convinced, and this is for sure, but instead it will augment them, enabling physicians to practice better medicine with greater accuracy and precision, and obviously with increased efficiency. With this, I would like to thank my organizers and listeners. If you have any query, please feel free to drop me an email in this. So,
Thank you, Dr. Kumar, for your enlightening
I think
session.
I have stopped sharing, right?
Yeah, no problem.
Okay, all right.
So, participant,
Yes,
do you have any queries or any questions regarding this presentation? Please, you may raise your hand so I can unmute, or even you can type in the chat box so we can pick the question.
Hello, someone raised hand. Sohail.
Yes, I'm checking. I'm checking. Yes.
Uh, uh, Hello, everybody. This is Dr. Indranil Mukhopadhyay speaking. I just have one question. Um, do you feel that federated learning could be something which could be very helpful in coming days, or is it something which we need to look in a different way?
Dr. Indranil, thank you for asking this question. I already mentioned in my presentation that this is the thing to look forward to, because we have been struggling with data privacy and ethical concerns for quite a long time. It was about whether we should send the data which contains patients' critical information outside the institute or not. So in the federative learning, what happens, as I mentioned, the model comes to our institute. The data doesn't go anywhere. So they train on those data, the models train on those big data, and definitely this is going to be the thing in the future. That's what I believe, at least.
Thank you very much. Thank you.
Miss Samriddhi Dev, do you have any question?
Yes, sir. Am I audible, sir?
Yes, you are audible. Please go ahead.
Yeah. Yeah. Firstly, thank you so much, sir, for your presentation. I would like to mention one point. You have just mentioned one point in your slide that there's a problem for regarding structured data. Like we have lots of data, but in unstructured format, right? So what
Yes,
I've
that's
done
correct.
is, yeah, hello.
Please go ahead.
Yeah. Okay. So the problem is the data is not in the structured format, right? So what I've done is I have developed an algorithm like which gives the automation and constructing the structured data set by taking the data in unstructured format. Like I have taken data from PubMed case reports. Like I have taken some 500 around 500 case reports that was freely accessible. The problem was the data is not freely accessible. So what I've done is I have converted into a structured format and developed an algorithm for that. But in the medical domain, it is not getting appreciated, and while considering publications as well, so it is not getting appreciated. Like the domain of mine was cancer, but so since I was not having any benchmark data, so I got my data set that I have constructed, got it validated by a domain expert. But still, it is not getting appreciated from the medical perspective. So can you please suggest me anything?
So the data that you have collected
Yeah.
are they the source was open? Was it an open source platform?
Yeah. What I've done is I put the query in the PubMed that the publication type was case report, and that is publicly available, and the time duration was from 1990 till 2014 yeah, 2018. Yeah.
So you have basically done a retrospective data collection, and
Yeah.
if
Yeah.
you
Yeah.
have so basically the individual patient data you could not collect. You have basically collected from the inference from the studies that were published, right?
Yeah. Yeah. Case reports. Yeah.
Yeah. So to we need to get those patient data. There are patient data available which in the form of metadata, and there are open source platforms where you can get those data. But at the same time, if you cannot run them in your existing healthcare setup, you won't be able to get maximum out of it. And there is a big ethical issue also is there because once you mention that you have taken the data from there and you do not have the permission, there is an ethical issue remains there, and that is going to be flagged while your publication. While you're publishing, the editor, the editorial board members are going to raise the flag that okay, you have taken the data, have you taken the permission or not? So it is going to be there. So I would suggest you try to contact the hospitals inside India and generate real-time data.
Sir, I tried contacting AIMS Delhi along with my supervisor, but they denied, saying that the data is confidential and we cannot reveal it for anybody, So
Yeah, so there comes. Okay, please go ahead.
Yeah, the problem. Sorry to interrupt you, sir, but the problem is not gathering the data. But the problem is it is not getting appreciated. The algorithm which I had developed to convert the unstructured data into a structured format, that particular algorithm is not getting appreciated. Reason being that we don't have any benchmark data to test that algorithm. So for that, I got it validated by the physical domain expert, but still it is not getting appreciated. Like
By whom? By whom?
So by the domain medical expert, as well as in the publication. While I tried publishing in the medical domain journals. Yeah, it always get rejected.
Okay, so in that case, see, in that case, you need to be visiting them and sitting down with them and explain them what you actually want to, publish. What are your clear objectives? If your collaborators, they don't know your clear objectives, the first specifically, I mentioned that the policymakers, they are stepping back because of data privacy breach. So it is a big thing when people are afraid that our data is going to get leaked. So if you somehow can convince them that patient's identity is not going to get leaked, you can get it real time. And still, I am not able to understand why your data is not being published in medical domain journals. What are the comments that you have received? Can you tell me?
So there are no particular comments. They are getting text rejected.
So medical publishing is becoming a business, I'm sorry to say, and you really need to kind of apply to those journals with a decent amount of funding and APCs. That's the similar issues I've been also facing, because within 2 hours a paper cannot be evaluated. Within 2 hours we are getting rejection messages. So it's just about the journal policy. We cannot help it. So we have to find the appropriate journal and send it. Yeah. To the kind of resistance that you're facing from medical fraternity, I would suggest you approach someone whom you can sit down with and explain them, because there is a lot of resistance because of these data privacy issues. So you have to convince them that your patient's identity is not going to get breached. So this is the most important thing you need to make them understand.
Okay. Thank you so much, sir. Thank you.
Pleasure.
Ms. Samriddhi, I suggest you to keep in touch with Dr. Abhijit Kumar for further discussion. Meanwhile, Mr. Tanmay Roy, do you have any question?
Yes. Good evening, everybody. I'm Dr. Tanmay Roy Chaudhary. Am I audible?
Yes, you are.
Yes, you're audible. Please go ahead.
Okay, Dr. Abhijit. The main problem from your session and what I have learned so far is that the main problem is getting real-time data from the hospitals, which you were mentioning. And the problem is with the data breaching and all. I seriously don't get it that it's a simple form of encoding just by removing the name and address of the patients, not the health stats. What is the problem in giving the data out to the researchers? Because it's a simple form of encoding. We don't need the name, we don't need the address. We just need the health vitals from the hospitals. Where is the problem? in doing such a simple form of encoding and giving the data out to the researchers?
I hope that's the same thing as I mentioned as de-identification, right?
Yes, yes, yes. The de-identification, doctor de-identification is probably a very simple task then. Then why is it so much of a problem nowadays for getting those ethical permissions and all? So
Because as I said, I think in the beginning, in the middle, at the end, it all boils down to the interest of the policymakers. So the policymakers, they don't want to kind of invest on these things. We don't have a data scientist in our institute. It's just we don't have a department. I'm not sure whether AIMS New Delhi has a department of. They have a biostatistics department. They don't have a data scientist who can spearhead these kind of things so that these data can be stored in a clean way, in a utilizable way, and it can be de-identified. The names and the identity can be removed from the data, and that data can be stored for further use. We have not yet implemented electronic data system, electronic health record system. We are in the process, but still not done. So we are far ahead, far behind, I feel. We need to somehow convince our policymakers that these are important. And the moment they hear these terms, they feel, yes, our data is going to get lost. So there we say data breach, and we will be in the news, and we don't want to get into any form of litigations. So that's a big problem.
But sir, is this not contradictory to what you are showing, that government is trying to invest so much billion rupees in healthcare, AI in healthcare, and then on the other hand, they are not.
That's the market size I mentioned. That's not the government being so much interested in it. The private players are being very interested because they want the data, and there is a market as well. But government is still, providing basics to patient, basics, bed, basic healthcare. When we go to villages, we see that I mentioned it as well. The mothers are still delivering at home. So, government is eyeing, as government is focusing on multiple strata, but the level of data cleaning and data storage and data handling that we're talking about, we are still not up to the mark. I'm so sorry to admit, but we are not still up to the mark.
Okay, thank you, sir. Thank you.
Dr. Ramesh Shah, do you have any question?
No, I got the answer. Just one thing I want to say in here, sir, talking about that meteorological implication. Just my question is that in the medical health science, I'm audible, no? Okay.
Yeah, yes,
In the
you are
medical
audible.
health science, how it is the issue or AI related work in healthcare?
Can you come again, please?
You talk about in the challenges in AI, meteorological implication. Okay. So my question is that how it is connected to healthcare challenge?
Medico-legal, right?
Yes, I think.
Okay. So medico-legal is, I gave you an example as well. Let's take an example that, please don't get me wrong, if you're suffering from fever.
Okay.
And to my experience, you're suffering from a bacterial fever. But my AI assistant, the interface where I'm documenting your data, is giving me a prompt that you are suffering from a viral fever and I should prescribe some antivirals. And I have prescribed the antivirals, noting down that, yes, this system is prompting me to prescribe you antivirals, and you developed kidney failure. Who is to be blamed because of those medication you have developed? Kidney failure, who is to be blamed, the AI system or a doctor?
Actually, in that cases, I think some features you should be include for the AI system. Okay.
Yeah.
So, if you give me an example as a fever. So if someone is affected by the, suppose for example, a corona, then feature is the different, na? then
So
how it is
it
connected
is
to?
okay. I get it what you're trying to say, but the entire responsibility so far is on doctors. So that is the reason there is a hesitancy in accepting those suggestions from AI based systems. And I feel transparency plays a big role into that as well, because we don't know how it works in detail. We don't have in-depth knowledge of how it is working exactly, what it is actually processing. So that is how the trust factor is still in a gray zone, that whether I should believe this or not. So that's why I choose to believe on my cognitive capabilities and motor skill while it comes to treating a patient. So that is a challenge we need to circumvent in days to come. It needs to be more precise and more data driven and more transparent.
Okay. Okay, definitely. This is also a challenge. Okay.
Yeah.
Thank you.
Thank you.
Do anyone have any other question?
The session is really interesting, as we can see a number of interactions. So anyone else?
Good evening, sir. So my question is, what are the challenges in mental health related to AI?
So the first and foremost thing is to diagnose mental illness, we don't have any diagnostic tests as we do for certain blood tests, imaging. We do not have certain tests. It mainly based on the cognitive features, the some of the behavioral traits. So if we can develop certain chatbots or certain questionnaires which is regularly being implemented, or some form of behavioral analysis of those individuals which we think are suffering from mental illness, and somehow we can integrate them with machine learning and deep learning, we can get an idea about how much they are swaying from normality. So if I am behaving in a single line and my mental health is keeping well, I can track any deviation from that. And so diagnosing can be easier. And once I get diagnosed, the algorithm, if it is properly functional and reliable, it can track my progress, whether I'm deteriorating or I'm improving, in the form of behavioral analysis, my day-to-day activities, my social media activities. And nonetheless, the virtual chat health assistants, chatbots, the virtual therapy sessions, they can also be very handy when treating a patient with mental illnesses. And these chatbots are frequently being used for patients who are having seasonal depression and major depressive disorders as well. So it has a long list of features that can be used for mental health ailments. But still, the more we talk about, the ground reality remains gray. The ground reality is still we are treating patients based on their behavioral traits. Still we are handing them over pills and we are giving them electroconvulsive therapies. So we are kind of a couple of miles away, I think.
Yeah.
I hope that served the purpose that you asked.
Yes, sir. Yes, sir. Sir, where we are lagging, sir? Can you repeat that?
So the main problem, as I was saying that the availability of data and reliability of those models. Yeah, there are models, but the reliability, the doctors are not well versed with those using those models. The inter-institute or inter-departmental collaborations are not taking that pace so that data scientists and researchers can come to us and make us understand the workability and the way these models work and how they can be useful. We read about it. I have read tons of literature. I try to talk to people, but again, collaboration, particularly in government institutes, becoming a challenge. Uh, it's a big challenge to get the ethical approval to do multicentric research involving AI, because always they flag concerns of ethical reasons, that whether our data is going to be safe, whether it is safe to whatever you are using, whether that is safe, whether there is a benchmark to it. So these queries we cannot answer at this moment. I hope in days to come, in 1 or 2 years, we'll be in a better place to answer these queries.
Yeah, sir. Thank you so much for incredible presentation and answer, sir. Thank you.
Pleasure. Thank you so much.
Thank you. I think this is a topic. There will be many of the interactions, many of the queries, many of the doubts of the researchers. So I think the email ID of Dr. Abhijit Kumar is with us, or we will give in the chat box, so that if you have any further queries, you can please reach to him.
Please feel free to reach out to
Yeah,
me. Yeah, thank you.
yeah. And now here we will conclude today's session. I think any other queries can be taken care of by Dr. Abhijit Kumar offline mode. Right. So just thank you so much. We extend our heartfelt thanks to you, because we always, as a researcher in this healthcare domain, we feel that there is a need of active involvement or expert feedback from medical fraternity people, because we people think from the technology or tools or algorithms related point of view, but the ethics, values, and the medical input or insight is very much required from the medical fraternity, and that's why we tried to reach you to. And we are thankful to you that in spite of your busy schedule, you have been able to join us and have enlightened on this burning issue that almost all of us we are facing nowadays, because nowadays research is all data oriented. Thank you once again for this wonderful session, and would be very helpful that if you please share the slide with us. It is already shared, or yeah, okay. Once we get it, we will share with the participants as well. And thank you so much, sir. Have a good day. And for the participants, yeah, thank you, sir. Good night. And for the participants, there is an announcement that the feedback link is shared, and the attendance link and feedback link is shared. Up to 11 p.m. it is open, and you please fill it up using your registered email ID. It is a must. It is mandatory to have the attendance recorded correctly and to be uploaded in the ATAL portal. And tomorrow again we will join 4th of February, and the first session will be 6 to 7:30. Topic is deep learning and explainable AI in disease diagnosis, and the expert will be Dr. Ushila Bandyopadhyay. And session 4, that is 7:30 to 9 p.m., will be the role of security and cyber threat mitigation in AI for Society 5.0. Speaker will be Mr. Nitish Kundu. So with this, we again wish you good journey ahead in this FDP. Thank you all. Good night. Sohel, Dr. Sohel, can we conclude the session?
Yes, we can conclude this. Thank you all for your active participation. See you tomorrow.
Yeah, and there are formalities, that for the successful completion of the ATAL FDP, there are these certain regulations on the attendance, on the feedback, and on the day-to-day attendance. And at the end, there will be examination. So with your patient hearing, you also please follow these things, so that we would be very happy to complete all the formalities smoothly regarding this FDP, and for that your active participation is really appreciated. Thank you all. Good night.